what we did is we drafted a new ERC, the ERC 7730. It's a draft. It's available online on Ethereum Musicians. So if you want to join the conversation and help us make this standard easy to implement and fit for your purpose, please join the conversation. And we're actually talking about this as part of the Clear Signing Alliance that the Ethereum Foundation announced on Monday. If you saw Frederick's talk, we actually are working on this with Fireblocks, Devconnect, Sourcify. They're all joining and are part of the conversation into drafting this industry standard that we introduced 2 years ago. And so the idea is to take the hexadecimal blob that I showed you earlier and to turn this into this, where you have a clear intent, review this message to swap tokens. You can see that you have the contract in plain English, and it's not just an address. You can see the tokens and the amounts, and then you can hold to sign or reject the transaction. You understand what it says, so you're in control, essentially. So it's going from this, blind signing, to clear signing, right? That's what we're talking about with this. So how do we make this happen, right? There are 3 steps to this. The first step is to create the metadata, to create the ERC 7730 file. What it is just a JSON that kind of allows wallets to know what information is what and how to display it to the user with the right labels, with the right parsing for amounts and all those things. To do this, we're providing a JSON creation tool to actually do so you can actually set the address to the contract and then import all the operations. And as a developer, you can then decorate all that information. Then the next step, once you have the JSON, is to have it in a central source of truth for the whole ecosystem to be able to feed from. And today, it's on a GitHub repository that's managed by Ledger, but we're looking to decentralize this with the Ethereum Foundation. It's very likely that the Ethereum Foundation will take it, but it's still in discussion with the Clear Signing Alliance. And then once you got this, you got the metadata, now is the integration for the whole system. So obviously Ledger implemented it in our products. Ledger Wallet, you can clear sign all interactions with key smart contracts out there, but it's for everyone to use. And Wallet Connect right now is actually building a library which will allow all apps out there in the space to easily parse and integrate this metadata for your wallets should you want to. So those are the key components. And so this is how it looks like, the JSON file that once you generated it. So as you can see, very simple for a developer to generate. It's not actually code. It's just how to parse the transaction. And here, as you can see, you have a clear label. You have the format so that then the wallet knows how to display this in the UI. And then the token path going like, how do I, in the transaction, is the first param from 0 to 19 bytes that should be extracted, and this is the actual amount to send. And this will allow wallets to actually show this in plain English. So that's the theory and how everything works behind the scene. Now let me walk you through what we did with Aave to make Aave clear signed on Ledger. Sorry. Okay, here it goes. So first up, you go on getclearsign.com. If you have a smart contract, it's already live. You can go online and make it happen. And you start by inputting your contract address. Then you'll be able to fill in metadata so that it displays nicely to the user. And you can see that you have a preview on our Ledger signers to see how it looks like. So here, contract owner, legal name, and that will replace the contract address, making it clearer to the user. And then you can pick up all the different methods that you have in your contract, the different operations. And for each parameter, you can then put a nice, clearly label and how to display this. And in real time on the website, you can actually see how it displays on our hardware wallets. Once you're done, you got the JSON. You take the JSON, you put it on the Clear Signing repo, which will decentralize the Clear Signing Alliance, as I was talking about, very likely with the Ethereum Foundation. And once it's there, then it's up for any wallet that actually supports the ERC 7730. They will now then be able to clear sign interactions with your smart contract. So this is how we set up clear signing. But the thing is that understanding it is one step forward, but we can do better than this. It could still be harmful if you have the wrong metadata inputted in. So this is why we introduced earlier this year in our Ledger wallet transaction check. And the idea here, if you remember what happened with the Bybit hack, is that they had transaction simulation, but they had it on the software side, and so the results were on the software. So now what we did is that we actually are showing the results on the hardware side, so done separately, and this way it allows you to double check and cross check with what happens on the software. And so this would have prevented the Bybit hack, for instance. So here's how it looks like. You have the transaction that is crafted. We send it to our partners, Blockade, Tenderly, Cyvers, that are then doing the transaction simulation. They then package the results, sign it, and then we actually show it directly on the signer. And so if it's verified and is compliant, you're going to get this screen right there, verified, which means that we haven't seen any risk. You can go and proceed to clear signing. But in the transaction simulation, if we actually realize that there was a threat, we're going to show you the report so that you know, and then you can actually then go back to safety and reject the transaction. So it's really clear signing and transaction simulation working hand in hand to protect your bag. And this works. What Blockade told us is that in the month that we've released transaction simulation, we've already prevented $20 million in losses by blocking transactions that were malicious and raising those to the users. So that's a win for the ecosystem. That's a win for security. And so this happens in Ledger Wallet. But now what we're introducing is, a month ago, we've just announced a new product for developers and especially for dApp builders, which is the Ledger Wallet button. And what it is that it's a simple button that allows direct connectivity from dApps to our hardware wallets. You don't need Wallet Connect. You don't need an extension to this. It allows you to connect to your Ledger Wallet via Bluetooth or USB from your desktop. You can see all your accounts that are actually on that signer. You see the balance, and then you go, and then you have clear signing straight from the dApp without having to navigate to another software wallet, go through an extension, go through the hustle of Wallet Connect as well. So it's a much simpler UX, and good UX means good security. So that's that. And actually, this is live on 1inch. If you want to try it out and see this new experience with clear signing, you can go right now on 1inch.com and try it out with your wallet and see the flow. And so this is we're rolling this out to dApps out there, really to improve connectivity and experience for all Ledger users. And then the other product that we recently announced a month ago. And this one is for any on-chain organization. So that's a B2B product, and it's for SMEs and DAOs and those kind of guys, which is multisig. They've been asking for a Ledger-supported multisig with clear signing for ages. And so what we've done is we've built a new front end on top of Safe that allows you to have EVM multisig. And it allows you to do this with clear signing. So back to my Bybit example, where they're using Safe, but they couldn't clear sign and then lost their crypto. Here, you have all this integrated very smoothly, and it's not you don't have to choose in between Safe and Ledger multisig. They are compatible. So if you already have a vault on Safe, you can import it, use it, try it out with our UI. And see for yourself with this brand new experience, the clear signing experience on it. And this is Ledger Multisig for on-chain organizations. So proactive defense, you have clear signing, and it's super simple, super easy to try because there's zero migration. It's not Safe or Ledger. It's both together combined in our unified dashboard with clear signing. And that's pretty much it. These are the news. I think the key points that I really wanted to share with you today is the risk of blind signing. You signing a hexadecimal or these big blocks that I showed earlier is just like signing a blank check. So please don't do it. You should be clear signing. Clear signing relies on an open standard, ERC 7730, because we want that for the whole industry and not just Ledger. We obviously have implemented it in our Ledger wallet, so it's available for all of you guys and free for all retail users. We're decentralizing it because we want all the clear signing metadata to be used by the entire industry, and we're working with the Clear Signing Alliance to make it so. And then we also are embedded clear signing on all of our new products, Ledger wallet button for retail customers using dApps out there and decentralized exchanges as 1inch, for instance, but also for institutional DAOs and on-chain organizations with Ledger multisig. And that's it for me today. I think we're ready to take questions. Should any one of you have any questions?
Thank you. Thank you, Carl.
Thank you, guys.
Yeah, any questions? Please, you can just raise your hand and a mic will come to you. Got one over here. Mic coming.
Hi, great talk, by the way. The clear signing is really interesting, but for like clear signing in like using AI, are you guys thinking about how AI can also be used for also interpreting this message? It feels like that could have been like much easier to do. What's like, I guess, the difference between doing a clear sign in this way versus just asking, hey, LLM, take a look at this RPC in this transaction and tell me what it does?
Well, first of all, we're doing it in the secure element on the device so that we're malware resistant. So you can't run an LLM in a Ledger signer. We don't have
inference.
the compute power,
You could
right?
still run inference, right?
Yeah, absolutely. So that's the first part. So we actually have a POC internally of, because there's about, if you look at dApp Radar, there's about 17,000 dApps out there, right? Smart contracts that we would need a clear sign, right? And so we have a POC internally that actually generates the clear signing metadata for those 17,000 smart contracts, right? So that would be a way to do it. And that's the first part that actually brings clear signing. But I think the other thing that the space and the current feedback that we get from everyone is, it's not just the metadata, it's also they want someone to verify, make sure that this is not a scammer, it's not a drainer that's out there. And so that's why we have this human component right now, and right now it's really about increasing the trust and get it going and get everyone to implement clear signing in their wallets, in our experiences, so that us as users, when we see one of those blobs, it's like, oh, something is fishy, I'm not signing this. And it's really about developing that first step, and it comes with trust. So that's why we're going step by step. So we are looking at this, actually, you're absolutely right, but it's not ready to roll out.
Any other questions? No? Okay. Well, feel free to grab Carl afterwards.
I'll be at the Ledger booth all day over there, so feel free to swing by. We can show you our brand new devices, the Ledger Nano Gen 5 and the old ones, and we can talk security. Cool. Thank you, everyone.
Thank you so much,
Bye.
Carl. We'll just have a couple minutes break. We're just waiting for the next speaker, actually. So, yeah, Sip from Status, if you're around, please come to the back here and get mic'd up. it 2 minutes. Just introduce you in a minute. Hello, hello. Now we're going to talk about Status Network and what they're building, how they're building a super app for crypto users, how it's going to be gaslit, it's private. And to talk about all that, we have Sip right here. Welcome him to the stage, please.
Thank you. All right, let's get started. So yeah, I'm going to talk about how to create gazettes and private ecosystems. And I'm Sip. I'm the lead of Status Network. So one of the first thing is when you think about privacy, and when most people think about privacy, this is what they actually see in their head. And this is a big issue because now we need to actually make the industry, but also the larger world, understand that privacy is not about like hacker in dark hoodie. It's actually about people. And what has been happening in the last few years, and specifically 2024, 2025, is literally an attack on privacy. A lot of governments around the world have been trying to exert some level of control, and you see that in India, you see that in the UK, you see that in the US, in Europe, in Canada. And the answer from most people is like, okay, sure, but what do I have to hide? Like, I'm a good citizen, I pay my taxes, I don't have to showcase anything to the government that should be bad for me. But actually, most of current social order is based on privacy. Governments run on privacy. Banks run on privacy. Hospitals run on privacy. Literally, most of the social layer needs privacy to exist. Imagine if all your health data was available publicly for everyone, or if your tax data was available publicly for everyone. I don't think people would be super okay with that. And the fundamental reason is because privacy underwrites trust at scale. Like, you can't have trust if you don't have privacy. And it's a very serious topic, of course, but it needs to be de-traumatized. We need to talk about privacy as we talk normally about literally any social or technical topic without making it seem like, oh, we're all super criminals. So I would argue that it's a human right, and I would even say that it needs to be normalized, but even more, it needs to be encouraged. And that part is actually critical for me. And how to make it work is one of the ideas is to say like, hey, how about to make it fun? How about to make it seamless? And how about to make it actually rewarding? So I've been talking about like we need to encourage it, we need to reward it. And before getting more into like how we're going to do it, very quick word about who we are. So we are Status. Status is kind of an OG Ethereum aligned ecosystem. We've been around since 2017. We have been building a mobile app that does, it's a privacy first super app with mobile support, desktop support, and it gives you two key elements. The first one is a secure wallet, and the second one is a decentralized peer-to-peer end-to-end encrypted chats with your communities. Sister company is Logos. Logos is building privacy first full stack with storage, messaging, and of course the consensus layer. And talking about Status in particular, we have been building what we call the privacy stack. So what is the privacy stack? It's at the top you have the security. So we need to have air-gapped, we need to have a stateless, open source hardware wallet so that you can use it with literally no need to trust anything. You can verify the whole code, you can actually build it yourself if you want to. That works with standard cards. It's very easy to it's very easy to make it work in a fully open source manner. That is closely integrated within Status Super App. So the Super App is an open source cross-platform wallet with private communication that is deeply focused on Ethereum, of course, but is open, is multi-chain, and is open to all the communities that want to have that private space for them. And then below that, you have the chain layer. So why did we build a chain? It's because we wanted to provide a gasless way for the app users to actually be able to, invite people to their communities, like give them access, have people be able to transfer value between them without them having to charge a wallet with ETH and so on. So because we have so many services running on EVM chains, initially the idea was, how about we make it just a gasless chain just for Status? But actually, while doing that, we stumbled upon a way to do it at scale and to do it in a generalized way. I will talk about that just later. And finally, at the bottom of that, we have a client. So for those who have been to the ETH Client Day yesterday, Nimbus presented their integrated single binary code for consensus clients. And so yeah, it's Tornado Cash. But what actually happened is like most of those fees, most of the ETH is kind of a legacy. It has been going around for a while. No one is actually using, like depositing and withdrawing from Tornado Cash that much. So it's just ETH laying around. Then the second top is Railgun. And Railgun, actually that picture was taken 2 days ago. So I think it's way, it's way lower now. But yeah, you have 50 million here, which is nothing. I mean, 50 million on a $300 billion valuation. Basically, we don't have any ETH that is really shielded, except for Tornado Cash. And one of the main reasons is because it doesn't do anything. And so for us, private yield is the key. We need to be able to provide composable shielded ETH that earns yield that you can collateralize in DeFi applications as you would do with literally any other ETH. So this is where Status Network enters. So we are a gasless, private, and rewarding L2. I'm going to get into each of those topics. First, gasless. So what we do is we provide free transactions to all users and to all apps based on reputation, not gas. So you don't need to have ETH in your wallet to be able to interact with the Status network. How? We use ZKPs to prove, for each user to prove that they're not spamming the network. So at every transaction you make, you just say, hey, I'm within my throughput, and so I'm good. And as your engagement with the network increases, so as you deposit more assets, as your LP, as you use the apps, your reputation goes up, and your throughput of free transaction goes up as well. It's private. We have an opt-in composable privacy layer that people can use to shield, if they want to, their ETH and to interact with DeFi protocol straight from the privacy pool. And finally, it's rewarding. We have a sustainable shared native yield. I'm going to get into that right now, actually. So how does it work? Remember the reputation I was mentioning? So that's, oh yeah, it's not working here. So if you stake our token or provide liquidity, use the apps, basically do anything that is beneficial for the network, then you will get Karma, which is our soul-bound reputation token, and that will increase your reputation. As you increase your reputation, you unlock more free transactions. And how does the chain make money? Because most of the chains, they make money through sequencing fees. Well, we make money through bridge yield. So all the assets on the L1 that are deposited and that can earn yield are actually productive, and all the yield is bridged to the L2. And we also make fees through native app fees. So we have a native DEX, native CDP, stablecoin, native lending market, native token launchpad, and native privacy layer. And all of them generate fees, and all those fees feed into the native yield pool. That native yield pool gets voted on by reputation holder to allocate them to different projects, to different assets, and different LPs. And part of it, of course, pays for the L2 operation that allows the gasless transactions. It's private. So remember I talked about that optional privacy layer. This is where it lives. So we have a very regular vanilla zkEVM L2 network that is public, of course. On top of that, as regular, we have the EOA accounts, the smart accounts, multi-sig, and so on. And then from there, of course, you can interact publicly with the apps. So that's normal. But you can also decide to go through that native privacy layer, basically deposit into it, and then from them interact with the DeFi protocols, either using the adapters straight from that pool, or leveraging the gas infrastructure to basically create fresh new accounts. We call them ephemeral accounts, and that can use also ephemeral relayers that are fully gasless, so you don't have that gas trail that is going to link those accounts to your original accounts, and then interact with the DeFi protocols and all the apps through those ephemeral accounts. And finally, it's rewarding. So the strategy that we're after is to focus on assets. We think assets are the key to understand the differentiators between network. Now, you are not going to bridge to a network just to try Uniswap. Why? Because Uniswap is on most chains. So apps are not really a differentiator anymore. What is actually differentiator are the assets, like the native assets that were minted on that chain and that you need to bridge to that chain to actually get access to them. So I'm not going to get too much into the details because we don't have much time. But basically, the idea is that we create concentrated liquidity pools directly within the privacy layer. And we pool together assets that are earning exogenous yield. And on top of that, we add our native yield. So the cool thing is that suddenly you have assets that are non-leveraged, that don't have any liquidation risk, but that are yielding about 1.2 to 1.8x what you can earn on the mainnet. So you have actually kind of high yield, but with pretty much low risk on shielded assets. So you have assets that are private and that are earning yield and that are providing liquidity at the same time. So you have kind of a three advantages into a single asset. And so what are the benefits? Yeah, you increase your on-chain liquidity. You actually are earning superior organic yields. It's not leverage again. You increase the privacy sets. One of the biggest problems that I was mentioning about ETH not earning yields is not really because people don't earn yield. It's also because it reduces enormously the size of the privacy sets and the anonymity sets. So it means that you need to have many more people using it and many more ETH to be deposited into it, so that suddenly your privacy set increases and you have a kind of a decent privacy at this moment. So doing that kind of asset-first strategy is a way for us to offer a very simple way for users with a kind of a zap in, zap out, very kind of one-click interaction, offer users a way to get access to those yields and to those private assets without needing to like have a PhD in cryptography to understand what's going on behind the scene. And finally, this is actually something very new, which is it unlocks private bridging. So because we have that native privacy layer, it means that bridge operators can basically deposit their LP directly into the privacy pool and bridge across chains going through that privacy pool. So it's kind of a very nice unlock also by that model. And for solvers, it actually solves a lot of issues for them because it's gasless, because it has yield, so they are not, for traders or for market makers that are really preserving that privacy because it's a competitive edge. They can basically trade directly from the pool here. When? So Keycard is open, the hardware wallet. You can pre-order it right now on keycard.tech. Status app, there's a new version that just went out on the app stores, so download it, try it out. And finally, for the L2, we are opening the pre-deposits in the next 2 weeks. SNT token, Linea, ETH, and USD. And then we launch mainnet early next year. Oh, yeah, it's 2026. Yeah, I'm missing a 6 here. So yeah, the main goal for us is privacy for everyone. Basically, put private apps in the hand of everyone. And if you're a developer, join us to build Status, an open source, privacy-focused, unified ecosystem to communicate through the messaging, browse through our private browser, trade, as you can see within the pool, if you want to, privately, and finally earn together. Okay, I kind of added a few slides because I knew that I had more time than usual. That I want to review why gaslessness is so important for privacy and how it enhances it. And it's a fairly new topic in the sense that gasless are not, blockchains have never been thought in the concept of gaslessness. But here we think that with that new way to build chains, we unlock kind of key features. For example, ephemeral gasless accounts. I also already mentioned it. Gasless bots. Is actually something very interesting that we're after. So if you're building bots, please come talk to us. We have a bunch of use cases for that. It also supports time-based execution, which is something that in blockchains has always been a big issue. Because if you want to have a cron, for example, running or have some like time lock contracts that needs to take action after the time lock expired, you need to have gas. And then you need to have an account, probably a paymaster account that is going to pay for that. You need to already have kind of a whole architecture behind just making a very simple cron with a date at which it needs to be activated. And so here, because it's gasless, you can have gasless relayers that are going to take off-chain instructions and directly put them on-chain without worrying about gas fees and paymaster accounts and so on. So it really reduces a lot the overhead cost to run that. And with the you've probably seen all the talk about X402. The problem of X402 if it's made for stablecoins. So you need to have a stablecoin in your account to be able to use X402, but it's still on chain, so you still need ETH. And then you need to operate like a whole range of services on the side just to be able for your bots to have some gas to trade with. So here, because it's free, your bot can basically just have USD and nothing else. And finally, this is something very new. I think, which is free noise creation. So one of the biggest problems, as mentioned, is the size of the anonymity sets in privacy pools. If you have bots and basically gasless accounts that are just doing round trips between the privacy pool and the public network, then suddenly it's become harder and harder to track what money enters and then goes out of the privacy pool. So you really increases the size of the anonymity set. Okay, one last word about compliance, because we all love that. So the reality is that in 2025 now we have multiple tools to enable compliance. We have like the most known for like privacy pools, for example, is Association Set Provider, ASP. If you look at ZK protocols, most of the time they use viewing keys or selective disclosure. You can also have proof of innocence, PPOI. ZK KYC, if you used a ZK passport or if you participate into the Aztec sale, for example, you have been using a ZK KYC. You can also have like privacy modules, adapters, simulation, like all the tools around monitoring in real time and so on. So we don't have a problem with compliance. It's not a problem to be compliant. The actual problem is why, at which point do we stop, right? Like, and then, of course, we're going to be compliant with OFAC, because otherwise we're going to prison. So, cool. Then we're probably going to also be, with the DeFi hacks, we're not going to let them happen. Sure. AML, so anti-money laundering, of course we're respecting the laws. Counter financial terrorism, yeah, sure, all right, fine, we're going to comply with that. Activism, are we going to actually open our code to the government so that they can go after activists? Yeah, I'm not sure anymore. So that's kind of my last word around that topic is, it's a spectrum. Decentralization is a spectrum, privacy is a spectrum, compliance as well. And the problem is the moment we give a backdoor or a way for regulators to have access to certain data, they will use it. And they probably abuse it well. So if there is nothing technical stopping them, it will be abused in the future. If a God mode view exists in the network, you can be sure that at any point in time, it will be used. So to achieve real privacy, we need a system that can't be forced to comply. So actually, Vitalik did a whole talk about that. It's like, you know, the whole like, don't be evil, can't be evil. That's the core of it. Like, if we can't be compliant, or if the government can't have access to certain data, then the developers shouldn't be in a position to be put in prison because they just wrote code. So decentralization and credible neutrality are necessary for privacy. So all the blockchains that are focusing on, you know, faster server and so on, that's cool. But the moment they get a subpoena, their entire thing goes down. So if we don't do that, we're basically building the panopticon. So everything is observable by the government. And we are just handling the keys to the most elaborate sovereign system ever done. So that's not the point of what we're doing here. So that's why we need to have that in mind when we build systems focused on privacy. All right, I'm done. Thank you.
Thank you, Sib. We have a little bit of time here for some questions. So if you do have a question, just raise your hand. There's one over here, I see already. And Mike will come to you. Don't worry. And thank you for the talk. It's very nice to get an update on status and the whole privacy stack that you're building out.
Yeah, thank you for the talk. It was really good. I really like your last 2 slides. But just based off that, curious how you will actually look at implementing any OFAC kind of regulations. Like, what's your plan, where you're going? I kind of agree. Like, we don't want to be funding Lazarus to, you know, wash transaction L2s. But then again, we also don't want our devs to actually go to prison for just building tools. So what's kind of your approach on that?
Yeah, thank you. So I kind of joke with my team that my wife will kill me if I go to prison. And she would be right. So I'm not going to prison. So the way we've been thinking about that is we need to be compliant with the most basic rules that everyone agrees on. OFAC, that's why it was kind of the top of the list, because it's the most agreed on list. So the way we are doing it at the moment is basically at the sequencer level, we just implement a block list, and all the addresses that get added to that, we update that list once in a while when OFAC emits something, and those addresses can't, so they can't have access to the sequencer, but they can't even bridge. So they basically stay on the L1. The tricky part is when we go down the list, right? Because then there's not a kind of internationally agreed list of addresses that needs to be blocked. Then it's mostly based on threat models. So you look at, oh, we think Lazarus founded that few addresses, then yeah, all the addresses that are downstream from them needs to be taken out. So that's why also we, when thinking about the privacy layer, we want to implement a ZK protocol that allow us to do discrimination at the point of withdrawing, meaning that we can't filter for everything because we don't know what's happening in the world at any point in time. But if something happens later, we need to be able to say, hey, by the way, that address that enters with like 5 ETH, it's bad. So all the things that are downstream from that need to be excluded. And the way it's going to work, so there's actually 2 ways. First way is how Privacy Pool handles it, where you separate yourself from the bad address. So like all the people in the pool are just going to move pool and going to another one. The UX is terrible. It will get better, but that's the first way. The second way is, and I had like a nice talk with Aztec about that because they are thinking about implementing similar things, is you just can't withdraw. It's just blocked. And so it doesn't benefit anyone except ETH because it's basically a burned asset. So yeah, this is how we're thinking about that. So Logos, our sister organization, is going way more kind of intense into that route, like super cypherpunk thing. On my end, I want to provide something that is compliant, that anyone can use, and where people don't feel that they're criminals because they're using it.
Great. We got another question right here.
Hi, nice to love the talk, and I think this is so needed. But my concern is like, you know, when people know that you build private systems, then yes, you're right, they come after you. And I was curious, like, you know, with private systems and with the world and how it's changing today, do you think we have to release something that is powerful, like how Satoshi released Bitcoin to the world? Is that we have to do the sort of the zero knowledge version of the same thing, so like the Satoshi version of this? And I guess, do you have any opinions on how to release this kind of technology in a compliant way where you at least disclose the dangers of these sorts of systems, but then you at least provide some architecture or some guidelines on how people could start to use this, regardless of who ends up using it for malicious reasons? Like, what's your thought on enabling people, like standards of operations, but for decentralized network management regarding private compute?
Yeah, thank you. I spent years thinking about that, and the first network who did it well was Aztec. ZK Money, Aztec Connect in 2019. That was a great implementation, but it was still too centralized to be fully compliant and also fully protect users. And this is why they shut it down. They were like, yeah, actually it's a good tech, but we still have too much access to it that if at some point the government comes after us, we're done. So that's why they spend so much time building the new version of Aztec that is honestly, like, okay, I'm going to shield Aztec here, which is not good for me because I'm doing like another layer 2, but Aztec, I think, built the best way right now to do it because of two reasons. First, they don't run any sequencer. Literally, the Aztec team doesn't run a single sequencer. All of them are run by the community. Second, they don't operate a standard bridge in the sense that there is no canonical bridge to Aztec. There are multiple bridges. And bridges are super key into privacy because L2s are basically just bridges. It's just like an L1 contract that has some off-chain computation happening. That computation can be private or public. In their case, what they decided on ultimately on the design was to have multiple different bridges that all share a computation layer, but they don't share state, which means there is no global state in Aztec, which means that if you enter with dirty money and your money gets flagged, the bridge is responsible for that, not Aztec. And that completely changes the way we see compliance because then we see it really as a spectrum. Because you're going to have bridges that are extremely strict into what they accept, and you're going to have bridges that are extremely centralized and just don't care about anything. And I think this is the best system because it allows for multiple use cases without putting the Aztec team in a problem. Yeah.
And you're not afraid of like central relayers in this case, like that maybe leak the private compute over this channel? Because, you know, speaking networking wise, like, do you think there's any kind of problems there? Like, you might want a bridge, but maybe that's the moment of reveal. Because I know in zero knowledge, it's still not private if it's still trusted, based on the way that it reveals, like, the actual accumulation phase of a polynomial, for example. So
we don't have much time, so I'm going to answer very quickly. The idea is that what you're leaking is metadata mostly. And that metadata can be erased if you're using a Tor-based network or if you're using kind of somewhat decentralized relayers that have a trusted part, it's kind of TEs and so on. Personally, the way I'm looking at it is through the Waku perspective. So Waku is a peer-to-peer decentralized messaging system that is soon going to be able to run gazeless relayers on our network. And so if you can make the calls to those relayers using a Tor-based network, then your anonymity is pretty high. Also because the moment the relayer system catches your message, it can just pin out a new address and trade from there, which again increases a lot the anonymity sets. We are not a perfect solution in terms of metadata erasing, but I think we're good enough so that it's extremely hard for someone to track it, and we think it's a good enough privacy. Yeah.
Great. If you have any more questions for Sip, feel free to catch him afterwards. And you have a booth over here as well, right?
Yeah, we have a booth, but actually it's not manned right now. But just find me on Twitter at @TheOryxSip, and otherwise just find me around. I'll be around the whole day.
Great. You can consider him the walking booth. So try and find him. Perfect. Thank you so much, Sip.
Thank you so much.
And yeah, stay tuned. In a minute or two, we'll be talking about NIM VPN. So if you're interested in that, just stay right here. We keep the privacy topic going. Great. Like I just said, we're going to keep the privacy theme going. And next up, we're going to talk about NIM VPN. Max and Jana here is going to talk to us about NIM's noise generating network.
Mm-hmm.
And I'm just going to pass it right over to them, and we're going to learn more about NIM VPN.
Cool. Thanks, dude.
Okay.
Okay, hi. So I'm Max. I lead the DevRel side of stuff, and I also lead on our integrations front. And
I'm Jana. I'm a software developer at NIM, and I do represent NIM and explain our very complex technology in very simple ways.
so a little bit of an overview of the talk, right? We're going to go problem, solution, and then kind of continue to focus down further. So the problem is that at the network level, so before you start thinking about ZK proofs or anything that happens on chain, this is the thing that happens underneath that. It's as data travels between computers, right? And in that regard, generally privacy, digital privacy at the moment has a couple of big flaws. That's because of metadata and because of how then metadata is used in surveillance. How we solve it and then we'll talk about the NIM VPN. So the problem, right? Like the big problem. Like the talk that just happened before, someone had a question that was, I think you discussing leaking stuff at the network layer. People were talking about Tor, and people have been trying to solve this for like a long time, right? So we're not new in identifying the problem, but the problem has changed over time, and that's because of metadata. So metadata is data about data, and you can think of that in terms of whenever you send traffic between two computers, you want to make an RPC request, you want to just even like boot your computer up and connect it to the internet and get like the time from like an NTP server, right? You're going to be leaking, if you're kind of unprotected, by default, you're actually leaking like the origin, the destination of like where the request where a request originates from, where it's going. This is in the packet header. This is obvious for anyone to see if they're surveilling the network. Kind of the length of the packets, what you're sending, when you're sending it. Basically, think about metadata as like a set of patterns. And for people that are surveilling a network, patterns are what allows you to make inferences about stuff. This is exposed, as I said, by default. TCP/IP, HTTP, UDP, FTP, like all of these things were not really designed with the threat model of someone can capture massive amounts of internet traffic and scrape them and then start finding patterns and making inferences in them, right? Like a very kind of simple way of thinking about metadata is, say if you can see that there are two people who message each other, but you only message each other at like 2 a.m. on like a Friday and a Saturday night, what can you infer about the relationship between those two people, right? You don't need to see the contents of any of the messages they're sending each other, but you can already make pretty like big inferences about stuff. And who are these people who can like pull this stuff out, right? Basically, anyone who runs or maintains internet infrastructure. So your internet service provider, the exchanges, routers, basically all of the kind of internet like backbone that we just kind of have taken for given at this point. They can passively see all of this stuff because it's traveling through their infrastructure. In terms of more, let's say, aggressive attacks, maybe you have maybe your Wi-Fi router is running a botnet, maybe there's someone eavesdropping, and although this sounds very over the top, actually there are multiple NSA programs that the Snowden revelations showed are focused on just metadata, right? This is not just something that governments do, it's a business as well. And there's this quote by Stuart Barker here, the NSA former general counsel, if you have enough metadata, you don't need content. So the idea that encrypting your messages is like making you anonymous or protecting you is, maybe it was true at one point, but it's no longer really true now. And so how are we solving this? There we go, by combining the use of some of the security properties that blockchains give you with a decentralized network, like a decentralized node infrastructure, and agglomerated together. We refer to this as the noise generating network, or the NIM NGN. This is an overlay network, so this is like nodes similar to Tor that are running on servers all around the world that basically protect your metadata from surveillance with mixing, an anonymous credentialing scheme, which we'll get into later, and basically what we refer to as covered traffic, but you can think of as like producing white noise in a network, right? There are two ways that people can interact with this. One is via the NIM VPN app, which Jana will be talking about in a second, and the other one is the NIM SDK. So there are a couple of ways that there are a couple of things that we do, basically, when traffic is moving between these computers, moving through this overlay network. We'll go into each of these in detail in a bit, but the mental model going forward is, think of it as filling the network traffic with white noise and trying to hide any pattern of data which is leaving your device from that. So I will pass over to Jana now, and she can talk about the NIM VPN app.
Yeah, thank you so much. So let's look into detail how it works, how our noise generating network works. We've came up with a VPN solution which you can actually download on any of the platforms, and on top of it we have actually two modes, which is a very private mixed net or noise generation network mode and a speedier one. I will explain you the difference in a bit. So let's have a look, and to start, let's just look at a normal traditional VPN. So what happens? Besides the fact that it's centralized, it means it has all the data about you. It has your, let's say, email address, it has your real name, it has maybe the physical address where you have sent the invoice for payment. It also holds the IP addresses, your real IP address and the IP address it gives to you. So let's say if the law enforcement agencies is coming to them and they ask to hand out the IP addresses, the centralized VPN is able to hand out not only the IP addresses but all the information about you, and they have to abide to these rules. But even if no one is coming to them, it's just enough to look at the entry point of this VPN and exit point. You capture this traffic in some time, and then you compare their patterns, and then you correlate. And then you can actually see exactly who is talking to who without even asking for those IP addresses. So let's jump quickly to our solution for the NIM VPN, the MixNet. So before your traffic is coming into the entry node, into the entry point, it gets already changed into something that we call Sphinx packets, but it's not only our format, the Lightning Network is using it as well. So basically what it does, it takes a single packet, each single packet of your traffic, and makes it of the same size. So all of them look the same. On top of it, we also add noise, which is make it unclear when you're actually using the network and when you don't. And then the 3 layers of mixing is happening within our NIM nodes. This is what Max was talking about. So the packets get shuffled on each node, on each hop. It means that the sequence, when they come in and come out of the server, is being changed. These packets are shuffled with the packets of other users, with fake packets, and this is how we actually fight the pattern analyzation. And when it comes outside, then the exit node can decipher all of it. And when you say, okay, but at the end, it's the original pattern of the usage, which is also fine, because even if you capture this pattern, you have nothing to compare it to. And then, of course, the very legitimate question, so maybe this is a bit slow, and we do understand that there is always a battle between private and speedy. But if right now we have only the centralized speedy solutions, we have come up also with our own solution, which would be a decentralized VPN with 2 hops, and it would also mean that you do not leak your data, your payment data and your personal data to us. So what actually means, when your data is coming into the first server, yes, it can see you. Then the first server is sending it to the second server. It means the second server sees the first one and it knows the destination, but it knows nothing about you. So this speedy DVPN mode runs on the WireGuard protocol, and I will explain you why we have decided to use it in a second. So let's compare really quick. So centralized VPNs do not protect your metadata. They do not have independent servers, unlike, for example, Tor. Tor has already independent servers, but he doesn't protect your metadata, which is basically also the solution of our speedy VPN. That's why the most private solution would be a MixNet, which is the noise generation network. When do you use which? If you need something like browsing, streaming, video conferencing, you choose the fast WireGuard mode. If you need something more private for crypto transactions, emails, chats, you can choose our MixNet mode. So let's talk about something different now, that actually the problem of metadata inspection is not just the problem of the cypherpunks, it's the problem of the lots of countries. It also can be a problem which results into life or death question. For example, like in Ukraine, I come from Ukraine, and we know that Russia is using metadata surveillance techniques on us, but actually on all over the world, and they do their hacker attacks on different countries around them. So what do we do with this? And let's say we have already learned how to protect the metadata, but what about the blocking? Because very often the VPNs get blocked, and you might have already experienced, you go to some country and then you cannot use it. We have came up with a censorship resistance roadmap for this year, and we have accomplished quite a lot. Let's look into detail what we've done. We start with the Amnesia WireGuard protocol. So you remember I was talking about the speedy mode, so it doesn't use the mixnet in between, it uses the WireGuard protocol. But the problem of the WireGuard is that it has very recognizable packet patterns, especially in the handshake. So what happens before your phone or your device can send some information between you and the protocol and the server, they exchange the handshake, kind of saying, hey, I'm here. They then exchange the keys, and then they agree on to how they're going to encrypt the data. So this happens really quickly. This is automatic function, and so basically WireGuard has a very recognizable pattern. So what the sensors do, they find this pattern, oh, it looks like WireGuard, and they block it. So what Amnesia WireGuard does, and Amnesia is actually, let's say, a fork of WireGuard, it actually, amongst other functions, also changes the handshake, it changes its structure, so it's already on a higher level, it's a bit more difficult to block it. The next feature that we have also implemented is the Stealth API mode, what it is and what we use it for. So imagine a different problem, because VPNs can be blocked on different levels. So if the VPN is used by a lot of people, their API endpoints get known, and actually the sensors go and actually block the API. So what happens if your app cannot connect to its server, to its API endpoint? It cannot log in, it cannot download any configurations, it cannot actually connect. So your app just doesn't connect, it doesn't work. So this is done to a lot of VPNs out there, and so what we've came up with, we use the Stealth API mode. So how does it look? So basically, instead of sending the API requests to our own VPN endpoint, we send it to some well-known cloud provider domain, which looks very familiar, something really big that lots of people use. So in order to block, if the sensors block it, they will block a lot of internet. So what we do, we send it there, and then in an encrypted way, it gets rerouted to our original API. Well, this is a built-in feature. We do not want people to switch on or switch off, because we will switch on it. It's our fallback mechanism. When the API requests are blocked, that's when the Stealth API mode kicks in. And another thing that we've done, we have wrapped our WireGuard traffic, our WireGuard protocol, into the Quick wrapper. What is Quick? Quick is actually a word, its name is Quick UDP Internet Connection, and this is the protocol that lots of companies and internet sites are using. For example, YouTube, Instagram, Google. So it basically looks like a big chunk of UDP streaming. So what we do before you connect to the entry gateway, usually if the deep packet inspection can see the WireGuard packet structure and it can block you. So what we do, we exactly this connection to the first entry point, we wrap it into Quick. So think of it as a disguise. It looks as if it's just a big streaming network. So we've done it, and it helps us a lot. But let's say that's still not the last problem. Oh, by the way, yeah, this is a feature which you can toggle on. So if you feel like the VPN is being blocked, you cannot use it, you just go into our anti-censorship resistance settings and you toggle it in. And then, as I said, the entry gateway will have this small tag on it that it's enabled with Quick, and that's the one you will select and be able to connect. We continue with another problem. I will talk really quickly about it. So basically, we unlink your identity from usage, because usually if you buy a VPN, let's say even if your email address and your payment details are not being stored by the company, they still give you some kind of account number. So every time you connect, the VPN provider proxy will check with you if your account is actually valid, if you have access to use this VPN. It will create the temporary session token for you, and you will be able to use it. So basically, each time you connect, the provider knows your account number, and this is bad. So what we do, we've implemented a zero-knowledge proofs payment system. It works the following way. Once you pay for the subscription, it doesn't matter, it's a credit card, NIM token, or crypto. Under the hood, we buy the NIM token, but that's not the most important part. The most important part that our validators receive an order to create zero-knowledge proof keys for you, and this is like a huge amount of keys that you receive. So every time you connect to NIM VPN, NIM VPN is not checking your account address or your account number, it's checking one of those keys. And the only thing that's happening that our validators then check, is this key valid? And this is how we know that someone with a valid key is using our network. But who it is, we have no idea. So basically, we're not going into detail because that's a lot, but good thing is that now you can also pay for the NIM VPN with Ethereum, because this is a really fresh feature. We've worked on it exactly for the Devconnect, so that the Ethereum community can also pay in ETH. And we will go to something more that Max will tell you about our SDKs.
Before I do the SDKs, I'll also quickly introduce a feature that's going to be coming out in the next release of the NIM VPN app. And what that is a private RPC endpoint that runs locally. So this is a private RPC endpoint that you could essentially use for something like MetaMask. You could also, it's designed for MetaMask, but you could also use it in general. Why? Because if you're using MetaMask, you're using whatever, it's using a centralized RPC endpoint, like in Fiora. You know, a couple of years ago now, MetaMask changed their terms and conditions. Everyone knows that, like, as they get HTTP requests in, they can see and they are having a look for their own kind of like legal reasons at where an IP is maybe coming from and all of this kind of stuff. So actually using their built-in RPC endpoints, which is what the majority of people want to do, leaks your metadata, right? This is obviously, in the context of this talk, not a very good thing. So what we've done with this was built by a community member. What we actually have is now within the NIM VPN app itself, when you toggle on this kind of additional local proxy mode, it actually starts up it uses our SOCKS 5 client. So SOCKS is just like a set of proxy protocols. And basically it will start a SOCKS 5 NIM client locally that you can run to. That will then give you a local host address that you can basically just put into your MetaMask. So then you can configure it once to this local NIM network, and then all of your RPC traffic, even though it's actually being signed and sent from the MetaMask app itself, it will actually be going through the NIM VPN SOCKS 5 client, and it will be proxied through the mixnet to whatever endpoint you want to use, right? In doing so, you're unlinking the sender and receiver. You're no longer leaking any of this metadata, like your, whatever user agent, your connection type, all of the kind of stuff that comes with like a bog standard HTTP request, right? And this is actually going to be, like I said, it's going to be bundled into the next release. So it will be another toggle in the next release. You can just toggle it on. If you're already running the NIM VPN, then you might be running it in the speedy mode, this WireGuard tunnel in a tunnel mode. But this will actually then be giving you the full protections of the mixnet for your RPC transactions as well. And yeah, it's in the next release. And very quickly, for anyone here who's also a builder, we also do have 2 SDKs. So at the moment, we've been talking about the NIM VPN product, the downloadable app for all of the different operating systems and platforms. But we do have 2 SDKs as well if you want to bundle the capabilities of a mixnet into an existing application. We have 2 of them. We have a Rust SDK one. This is kind of broken up into a set of modules. If you want to build, if you want to get really deep, we have some of those as well. And we also have a couple of, let's say, more like plug and play abstractions as well for maybe developers who just want to use the mixnet, but they don't necessarily want to kind of fiddle around with building their own connection logics. And then we also have a TypeScript SDK. And the TypeScript SDK, basically we take our NIM client, we bundle it as a WASM blob, and what that means is that actually it can be imported into apps in the same way that any other dependency can be pulled from NPM, right? So it does work in a browser. Browsers are very restricted environments for arguably good security reasons. And what this basically does is this will sit inside a web worker. So what it means is that you can actually embed a NIM client onto a web page if you want to, and then actually be sending traffic through the mixnet from a web page, and your user, there's no kind of special configuration or anything that the user themselves has to do. If you go to our documentation, there is a playground as well for the TypeScript client, so you can actually send and receive data through the mixnet, and you can also use our library, which is called MixFetch, which is a mixnetified replacement for the browser's fetch API. So you can do from your browser, you can do HTTP requests through the mixnet and protect yourself from that without really having to do any additional configuration. We're almost out of time and we want to have time for questions, so download NimVPN here. This is all of our information, and thank you for listening.
Thank you, Max. Thank you, Jana. We have time for a couple of questions, so if anybody got a question, just raise your hand and a mic will come to you. One right here in the first row.
Hi, how are you? I'm Valentin. Nice to meet you
Nice
guys.
to meet you guys.
My question is, how can we get involved and how can we support NIM's mission? Because running a node, it's expensive and, the plutocracy around that.
Mm-hmm.
But how can we, I believe in the mission of freedom of speech that NIM provides. So how can we also, help with the mission of NIM without having to actually spend on a super complex machine to run a node or...
Yeah, I mean, so on the side of node operations and stuff, then so we didn't have time to get into it because it's like a talk in and of itself, but basically part of the reputation system of nodes, which is how they're selected to be involved in the network, right? Which is also part of a Sybil defense mechanism to stop someone just spinning up 1,000 bad nodes, is partially wasted on delegated staking. So there is this that you can do as well. You can stake on good nodes, you can support good nodes as well. You could have a look on the forum. People have already kind of started building with the SDKs, stuff like this. And a lot of the way that attention and grants are also kind of moved around from the forum is based on what the community wants to do as well, right? So there is also that. On top of that, we increasingly have more and more community-driven events. And a lot of community translations as well for both the website, the blog, all of the information as well. So there's a lot of kind of different ways that you can quite easily start kind of getting involved, or just start building with it as well. We have a bunch of people here. There's a bunch of us who are going to be at the Cypherpunk event later today as well. So just come see, hang out, and yeah.
There is something I want to add, but even if you do not build, even if you do not run the node, even if you do not stake the NIM token on the nodes, which is pretty easy to do actually, you still can use NIM VPN and you will be supporting the system because you remember about that noise that Max was talking about. So imagine this, that actually the more real traffic we have, the less noise we need to produce. So you using yourself and you being private in Mixnet, but also you protecting others because you add additional layers and additional packets which are taken into the computation. So you can support us by using NVPN.
Yeah.
Thank you.
No worries.
Got one over here.
I'm excited that this exists, and I'm happy to discover it. I have two questions. What's the overhead for noise generation over networks? Is this a way that you're unlocking unconditional privacy? The overhead cost is roughly...
by overhead, okay, so NIM is very, very client-based, right? The clients are doing the majority of the work here. The clients do your encryption, they do your routing, they do all of this kind of stuff. That does add somewhat of a computational cost. However, that said, I have also run 20 Mixnet clients at the same time on just a fairly normal ThinkPad, and it's fine. So you're not talking about, you turn on an M client and all of your CPUs kind of start whirring, right? So computationally, it's not that heavy. Obviously, it's more heavy than an HTTP client. But looking at the NIM VPN especially, then you could also have that. it's negligible, I would say, right? It does affect your battery life a bit, but like it's fairly negligible. Almost out of time, and the phrase unconditional privacy is a talk in and of itself. I would say, looking at what we're essentially building for, which is how do you defend yourself against a God's eye view? How do you defend yourself against like a global passive adversary, right? That can watch the ins and outs of a network and try and trace packets through it. That is essentially what the mixnet is an answer to, because surveillance is at this point I'm completely blanking on the word. It's a numbers game, right? You're making inferences about patterns that you find in data. What we're trying to do is hide all of those patterns itself, okay? From a GPA, someone like a government, a very large company like Amazon, someone like this who can actually capture all of the packets that are moving through a network and then start trying to do this linkability. That's what this is an answer to, basically.
And really quick is, for builders out there, for NIM specifically, I guess like what are your opinions about the use of TEEs for enabling sort of like my own personal confidential rail that would still enable NIM VPN? Is this something that you've seen?
I mean, a T is.
The privacy party will continue. Tyson from Zora is here. He's going to talk about the role of privacy controls in scaling crypto adoption. And I'm just going to pass it right over to him and take it away, Tyson.
Cool, thank you. Yeah, hi. I threw these talks together like 30 minutes last night, so we're just going to run with this and see how this goes. I've been thinking about privacy for a long time, especially at Zora. For those of you who don't know, Zora is a social market built on crypto where every post, profile, and project is a coin.
Very big below Fileverse, if any of you guys are here. To work only with partners that have similar values as you and do not abuse the user data. Use open standards and always give the user the choice. Do not just impose partnerships and integrations to them. So getting to the practical stuff that you should do as a builder, don't take the easy way. Don't go SaaS, the SaaS way, but start by defining the data lifecycle and where it's stored. It's really important to make it obvious that data is local and show that to the user. Think and iterate who your users are. make a profile for who is supposed to be using your product, and relentlessly iterate and build your app to optimize for this. Find a business model. Don't be free, and really get used to the idea that people should pay for what you are doing. Also, don't be afraid to price your product high enough. You are worth much more than you think, and do not sell yourself short. Like, this is really, really important. I have made this mistake. It cost my company, it cost my personal life. Really, really, really do not sell yourself short. Do make the pricing high enough. Users, ask where your data lives. Every single application that you use, can you use it if the internet goes down? If the website goes down, or the coin lists and the coin trackings of the world, if they just switch, flip a switch, will you lose everything that you have been working years for accounting, like to make it nice? You will. I'm telling you so. So do not use such applications. Make sure that the app can survive its creator and that it can work offline. And if an app does satisfy all these criteria, then support it and seal it to others. The vision is a network of aligned applications with the users in control and generally a continuous feedback loop. Happy users are supporting the applications get enough funding to become better, the users become happier, they become empowered, and then we have basically many such small aligned applications that are all working for users and are not just 3 big data mining giants that make all the apps. So remember, build aligned applications. Alignment is punk. It's basically a rebellion against the people that just built SaaS to mine your data and sell it to you as free products. That's all. Please stay aligned. Use Rotkey. We welcome open source contributors. This is a QR code with a link tree for all of our stuff. If you like Rotkey, buy premium. You can sponsor a release. And generally spread the word and come by our booth later. Thank you so much.
Thank you, Lefteris. Are you running out, Lefteris? Can you take let's see, if do we have any questions? Lefteris is running for another talk in about 20 minutes or so.
But I'm good, I have time for questions.
Okay. If you have any questions, just raise your hand and a mic will come to you magically. Okay, it doesn't have to be about the presentation. You also have a guy here who's been working on Ethereum since 2014 and has been involved in many different things. And Lefteris, you've been to every single DevCon?
No. Devconnect in Amsterdam, I missed it. Because I thought it wasn't the DevCon, so I was like, I'm not going to go.
I see, okay. So every DevCon and almost every Devconnect?
Yes.
Okay. Okay, but that's a strong track record. Okay, Hugo.
Hey, thank you. Thank you for remembering my name, Martin. I have a question on value. I know we talk about a lot of privacy, and I didn't catch, maybe you mentioned this at the beginning, I couldn't catch it yet, but do you have any idea or feeling of how much users price privacy? I know it's very difficult and diffuse to actually think about like the price of privacy and how much value it brings. Certainly Apple, for example, is pushing privacy as one of their selling props. At Peanut, for example, we do fees, right? There's fees on the transaction. So my question, like, hey, how much more expensive am I as a user willing to pay for something as long as it's private? Is it like double? Is it like just 5% more? Do you have any idea on like how to make this a number, a concrete number?
It really depends on the user profile. There is users who think that the stuff that I build are not private enough. There is, because privacy is not like a Boolean, it's a spectrum. I think that the majority of users would not be willing to pay more than 10%. Majority, like if you take like the average as a prop up of a normal other app. But there are users who would pay you the world if you can do specific things for them. Okay. But yeah, it's a very difficult thing to put a number on.
Okay, thank you.
Any other questions before Lefteris runs off? Otherwise, they can catch you at the booth later in the afternoon.
Yeah, I will be the booth, and I will give basically, I think, the same talk there in the privacy district.
Okay, so if you can't get enough, you want to hear it twice, right over there at the Privacy Stack event. Okay, thank you so much, Lefteris.
Yeah, my pleasure. Thank you, guys.
We'll have a couple of minutes break, and then we'll be talking about CK identity and how to prove your identity without giving up your passport and so on. Privacy. Yes, privacy, privacy, privacy. We are keeping the privacy party going. And next up, we're going to have what I think is going to be a very interesting talk about identity, how we bring privacy into identity. Michael is going to come up here and talk to us about CK Passport and something called Face Match. So please, give it up for Michael.
Thanks, mate. Okay. All right, thanks everyone that came to watch this talk. I'm Michael from ZK Passport, and I'm going to be talking about our brand new feature called Private Face Match. First, I'll go over what it is that we're building and talk a little bit about how it works, and then towards the end, I'll explain Private Face Match. It's a really exciting feature, and it's in production. So everybody in this room, on your passport or national ID, there's an NFC chip. And the issuing government has embedded on that chip your personal information. And then over that information, there's a digital signature by them, which is essentially an unforgeable seal. And so this allows us to now verify the signatures from your government signature on the passport to be able to verify your identity in a private way. And so the user flow here essentially is you will scan your passport or your national ID via NFC into your phone. And then you will scan a QR code on a website or a service connecting to the phone. And then you'll be presented with a credential request, essentially whatever it is the service is wanting you to prove about yourself. So this can be super granular. It can be like a proof of country. It could be just proof of humanity. It could be proving that you're not on a sanctions list, or any kind of combination of those. And then, importantly, everything is proven locally on device. So we put a lot of effort into this part of it. All the ZK proving is done client side, and it was a very big task to essentially allow it to be done within the memory constraints of a mobile device. So we can't really go beyond, say, like 2 gigabytes, because then we'd be excluding how many devices would be supported. And another important point to go over here is this concept of preserving the provenance. So you have the government signature on your passport, and you're not trusting us at all. We're basically just providing the circuits to allow that trust to be retained, and the provenance from the issuing government all the way through to the verifier. And this is in contrast to traditional KYC, where you'll be taking a passport of your photo, something like this, and you'll be sending it to a centralized KYC provider, and then they'll be reattesting to it by observing it, using whatever algorithm they have to go, oh, this looks genuine, I guess, and then giving you the service, the yay or nay. And it's a real shame because you have this provenance from the signatures, and you're losing it along the route. So they're reattesting to it. The trust is broken, essentially. But with ZK and what we've built, you can retain that, and that's a very important concept. And so we're building an open platform for digital identity, and this is available right now. So we launched about a week ago on mainnet and base, and we're going to go multi-chain. We have like a universal address for the root verifier, which is also pretty cool. So it's the same address no matter what the chain is. And yeah, we very soon will be having like a form where you can, any service can specify and select what are the credentials that they want, whether it's proof that you're from a European country, proof that you're not from a sanctions list, which sanctions list there might be. So there's like the OFAC SDN, there's several others. Or maybe you just want proof of uniqueness of being a human. And then it'll be a code generator that will generate the code that you'd need. Although it is also quite simple to plug into the SDK, as you can see here. But yeah, it'll then generate the solidity code for a smart contract or for the front end, and then you can just plug it in. And so here are some interesting use cases, some of which have already been put into production. We have, the first one is token sales or even airdrops. So this is actually a world's first, we're really proud of. This is the world's first ZK KYC. It was fully private, and this was launched last week for Aztec's token sale. So you have the fallback here with predicate as the traditional KYC, where you'd have to send your documents to them. But with ZK Passport, you can completely privately verify through a ZK circuit, ZK proof, that you're not from one of 4 different sanctions lists, and you're not from a sanctioned country like, say, North Korea and several others. So the services themselves, they pick the criteria, what it is, and then you'll scan a QR code as you're using the service, or in this example, participating in the token sale. And yeah, you get to preserve your privacy, which is the whole point here and why we're building this. So you also have proof of country. So we've partnered with, the slides are in the wrong order, but we partnered with Devconnect this year and also last year at DevCon. So you can prove that you're from a Latin American country, reveal nothing else about yourself, and you can get a 50% ticket discount. And this is a good off-chain use case. So there's no chain needed for this. You send it to the back end, a database sees the unique identifier, and it'll allocate you a ticket code, a voucher. And if you were to do it again, you would get the same unique identifier for your passport for that given service. So it would just issue the same voucher code again. And then we have proof of, okay, these slides are a bit messed up, but we have an integration with Gitcoin, with a passport, Gitcoin passport coming up soon. This is really handy for Gitcoin grants where they have the need for super resistance because of the quadratic funding. So this means that you don't spin up 1,000 different EOAs. It's limiting it to one person or one passport. And so sure, you might have 2 passports. It's a bit more common. Maybe you've got 3. It's very unlikely you have 4. If you have 10, your government's probably looking at you suspiciously, and you might end up on a different list for that reason. So this is strong super resistance. We also have another example could be proof of age, which is increasingly important given the regulations that are emerging from the UK, even Australia. So you want to be able to prove that you're over 18 without even revealing your age or any other information. Just the fact that you're over 18. That's the only credential that's being asked of you here. Why would you submit a photograph of your passport and all this information to that service? And especially sensitive considering what kind of service it is that you're sending it to. Like an adult website, for example. And then a great use case here is private and compliant stablecoins. So we believe that to get real-world adoption, you're going to need privacy for everyday transactions, this kind of thing. But if it is when you off-ramp or businesses accepting this, so you need to have some kind of regulatory compliance, proving that you're not on the sanctions list, for example, but you don't want to reveal your identity at the same time, just that you're not one of the bad guys. And so this is sort of an extension, I suppose, of the proof of innocence used by Railgun or privacy pools. But instead of it being an address that you're proving that you're not one of, it's your actual identity, like your name. So we can check against the OFAC STN sanctions list that your name does not appear there, and we transliterate different characters. We convert other character sets into Latin. Your passport number is not present there. It's a really nice extension on just a kind of a dumb EOA approach. And onto the, I guess the name of the talk is private face match. This is a really exciting feature. And what we're essentially doing here is allowing you to prove that you are the same person on your passport or ID card without ever revealing your face. So this provides a really nice guarantee, mitigates like scammers, or maybe you've lost your passport, so only you can use it. And this is something that's requested by the service for additional layers of security. And so the user simply scans their face using the mobile device. It'll generate, and this is all on device, nothing leaves the phone. Like your face never leaves the phone. A face print is derived, and then with an ML model, and then the similarity is compared against a face print from your passport photo, which is signed by your government. And this is all secured using what's called Appatest. So it's kind of it's a mobile TE guarantee. So everything up until this point is a cryptographic guarantee through our circuits, and then this is like a nice layer on top where you don't get a full, strong cryptographic guarantee, but you get very close to it, especially on iPhone. So it's proving in our circuits that it's a valid, that it's a genuine iPhone that hasn't been jailbroken. And there's like hundreds of e-fuses that exist in the phone, and if any of those blow, Apple will refuse to attest to it. And the way this works under the bonnet is on the secure element on the iPhone, there's a private key that's generated, a key pair. And that key pair is only usable by Ziggo Passport app. And then that key pair is attested to, so it's sent back to Apple servers, and there's also a corresponding device key that's linked to this, and at the factory, when Apple or even Google or Samsung create these devices, they know which ones are genuine based on this key pair. It's a public key, essentially, that they store. And so there's this way to keep this provenance from the factory to the device, and so Apple will sign over this, Google will sign over this, and then we, in the app logic, will do the comparison of the face print with what's called a cosine similarity. Essentially, if it's above a threshold and you look similar enough to the photograph on the passport, then it'll pass. And we embed that information, and then our app signs over it through the secure enclave on the device, and then we verify all of the signatures all the way through the chain from Apple and from Google through their version, which is called Play Integrity. And at the end of the day, you get all of these proofs in a very robust system inside the ZK circuit, proven locally on device. And then what emerges is essentially one proof, only revealing what is essentially like a root hash. And that root hash is the source of truth, the trust anchor that has Merkle trees and all this other stuff, but nothing private is revealed, and all of these assurances are there within the proof. And it looks like my laptop timed out, so let me get that going again. So yeah, crucially, with ZK Passport, what we're building is ensuring that all of the proofs are generated on device. This is very important. There's other ways to do this that are a bit of a cheat code and a shortcut, where they'll have a TE, and they'll encrypt the data for a key pair that the TE has, and then they'll send that data to the TE. The TE will decrypt it, then they'll do verifications normally. The issue with this is it's possible to eavesdrop on the TE, which is through what's called a side channel attack. This has been revealed very recently. It's not very difficult to do, and Intel have acknowledged it, and they've said, yeah, we're not going to fix that. It's not actually a design flaw. We weren't designing it to be private. We were designing it to have integrity, like a ZK circuit, but through hardware. And so the engineering effort was quite a lot, but we have 600 different circuits for all of the different signature algorithms, which is one of the biggest challenges. And we have these 4 subproofs that we generate locally. The first 3 verify the signature and all these other, like the root signature, the intermediate, and then finally the passport data itself. So those 3 subproofs can be generated immediately as soon as you scan your passport. And the 4th subproof, this is like essentially a pivot subproof, where you disclose whatever it is you want. We can cache those first 3, and then whenever you're proving for a particular service, then you're just generating that last one with a timestamp that makes it fresh. And those 4 are recursed into a single proof, all locally. Although sometimes if the memory requirements aren't enough, we can send those 4 subproofs to a cloud prover to recurse into one proof. But crucially, again, none of your data is sent off because they're already wrapped in these subproofs. This just basically allows them to be combined into one proof. We call it compressed proof, making it more compatible for the EVM. So you can send it to the chain, to a smart contract, have it verified. And this unique identifier can also be used in that context for example, limiting registrations to like a 1 passport or ID card per sign up. So this is all live in production right now. And we haven't actually properly announced through any announcements the private face match feature yet. But if you go to this URL, you can try it out for yourself right now. So you can load your national ID or your passport in. Crucially, the question mark FM equals 2 is the part here that you need to add, although this will be published to the main demo.zkpassport.id website very soon, maybe after Devconnect. We're all very busy right now. And then this is kind of like a choose your own adventure. So to give you an idea of what it looks like, this is the demo website, so you can choose proof of age, proof of country. And then if you add that, you can do private face match. So yeah, that's the flow. I'd love to take questions if anybody has any.
Great. Thank you very much, Michael. Yeah, if you have any questions, please just raise your hand and we'll get a mic over to you, ASAP.
Oh, shit. Oh, good.
Perfect. Okay, we got a question over
Hey,
here.
all right.
Mic is incoming. I think. You know, you can get my mic real quick.
Thank you, very interesting. Do you have a SDK for integration?
Absolutely, yeah. You can go to docs.zkpassport.id.
And you have a list of countries currently implemented, or all the countries are included right now?
Yeah, there's really wide support. So any passport that has an NFC chip will be supported. Most national IDs. There's some root certificates we don't have yet for some national IDs, but some use the existing infrastructure root certificate system. So yeah, there's a very high coverage. We also have a coverage map that you can view if you go to registry.zkpassport.id, and you can see the support and like a big map of all the countries.
Okay, thank you very much. Follow up. Do you also support like other type of ID, like driver's license in the United States?
Currently,
no.
no.
No. Okay.
But we do have plans to add this later on. So in California, in the United States, the system's different depending on the actual state. They do a different implementation. But yeah, we can do the probably California would make sense next. They don't do a fully decentralized model where there's root certificates. You'd have to kind of like send a request to the government website, and then you get back this signed JWT. Mm-hmm. It's a way to prove ownership of the ID, and then from there it's possible to do it. Yeah, but it's an interactive process, so we'd have to do that every time. But you'd still be able to prove it in circuit, which is what we're trying to achieve. And so yeah, we can add that later on, depending on demand. Absolutely.
Great. Thank you very much.
Thank you.
Thank you. Appreciate it.
You can just give the mic right there. I guess if you do that, you might have to consider whether you need to change the name. I guess CK Passport, if you do more types of identity.
Right. Yeah, we have thought about that, but now I guess we have enough brand recognition. It's kind of locked in at this point. So.
Yeah, makes sense. Any other questions? No? Okay. Well, you can catch Michael right after this, and maybe at the CK Passport booth as well.
Yeah, please come and visit us. We have a booth in that direction, in the Privacy Village. Happy to answer any questions you might have there. Please come and see us.
Perfect. Thank you so much, Michael.
Thank you. Appreciate it.
We're taking a quick little break here at the stage. I think we have our next talk in 40 minutes or so. So yeah, if you need something to drink, something to eat, feel free to go and get that. I highly recommend, if you are going to the food trucks and getting something to eat, try to pay with crypto and see these cool receipts coming up. I also heard there might be a POAP related to it, so check it out if you're hungry and you're going to the food trucks.
Hello, can you hear me? Can you hear me? Hi. Yes, hi. Hi, everyone. Welcome to afternoon session of the Stage Lightning Talks. My name is Abna. I'll be your MC for this afternoon. Super excited. We have a lot of interesting talks about privacy, identity, etc. And I hope you are with me. The format is like this. Each speaker will come, he has 20 minutes time. And then after 20 minutes, you have 5 minutes Q&A session. Whenever you have a question, just raise your hand. And then the mic will pass to you. And on each seat you have a headset in case you don't hear very well because of the other audience behind. You can just put your headset on and you hear the speaker very clearly. So it's up to you. I think we are ready to start. I'm happy to announce the next speaker. The topic is about next renaissance, about privacy, identity, and the future of Web3. We have a pleasure to welcome Zach Williamson from AdStack. Welcome on stage.
Thank you. Thank you. Thank you. All right. Hello, everybody. Good afternoon. How are we all doing? Last day of the conference. Let's all power through, eh? So I'm Zach. I am the co-founder of AdStack. And AdStack is a privacy-preserving layer 2 built on top of Ethereum. So we are recreating the permissionless smart contract ecosystem of Ethereum, that world computer, and we're making it private, where you can put private information inside your smart contracts and you can reason about that whilst maintaining all the canonical security benefits of blockchain. And I'm going to talk a little bit about why I think this kind of thing is so important, why privacy is important, how it's linked to identity, and the future of Web3. Yeah. There we go. So, okay. So, I think the information age we all live in, it's brought immense benefits to the world. You know, the information superhighway. Think about how easy it is to learn new material, new resources. However, there's been a very large downside to that, which is that it has eroded a lot of the foundations of trust that bind us together, these networks of obligation and responsibility that connect us to each other in the real world. The more of our lives move into a digital space, into online spaces, the more this erodes because we're not interacting with individuals anymore that we know, that we have personal links of accountability towards. We're interacting with random people online who can be anyone or anything. You don't even know if the person you're interacting with is a human being or not. Nowadays, it's probably a bot. You don't know what their agendas are. You don't know if they're lying. You can't hold anybody accountable anymore. This is all very much tied into the rise of the digital slop we're all encountering. And I think that we need new coordination mechanisms online that allow us to build trust infrastructure into the internet, into Web 2, as well as Web 3. We need new information networks to bring back what we've lost. And privacy is an existential part of what this is about. Privacy is going to eat the world in the same way that software ate the world 10 years ago, where you had brick and mortar stores that were so it's the year 2000, you have brick and mortar stores, you know, you've got filing cabinets with paper in them and information, you have data lying around on floppy disks, on hard drives, and all this information processing that an organization is doing, it's all very manual. It's all very primitive. It's all happening via people, primitive machines, on site. And software at the world because all this data got moved into the cloud. And all the information processing happened in digital spaces. And that led to the current world where we have Web 2 giants who hoard our information like a dragon on top of a treasure hoard, treating our data as their property. It's led to massive efficiencies, but it's also created these very negative externalities because that data can be monetized against our own interests. And I think privacy is going to eat the world in a very similar way, in a very similar process, where we're going to be building products and services that mimic the outcomes of Web 2, mimic that information processing. However, the data will be staying with the user, client side. It won't be shared. That data instead will be computed via zero-knowledge proofs. And permissionless distributed transaction networks like Ethereum, like AdStack, will be the settlements and execution layer for this information processing machine, in the same way that the cloud and AWS is for Web 2. And I think that we're going to have, because of the benefits of permissionless composability, the efficiency of these services is going to be higher than the Web 2. That's the bet. And that is, we're going to start to see a process of all this data leaking out and falling out of these Web 2 giants and going back into the hands of users. I think this is the world that a lot of people in this building want to create, want to build, want to participate in. and Aztec is no exception. Okay, so how the hell is this all linked to privacy? Well, I want to pose you something. You know, everybody says blockchain is a casino. No crying at the casino. And I love the casino. You know, don't take Polymarket away from me. It's absolutely hilarious. But we all want it to be more than a casino. And I can explain very succinctly why we are in where we are today. The fundamental value sources on blockchain today only come from two sources. They come from dollar-backed stablecoins and economic consensus. By economic consensus, I mean how much are people willing to pay to get transactions onto a blockchain? If the value of Ethereum, if the Ethereum token went to 0 tomorrow, every single token on Ethereum would also go to 0 except USDC and USDT. I think we all know that this is broadly true, which means they're all coming from the values coming from the same sources. The values all being derived from the value of Ethereum, which is the value of economic consensus. And what I want to highlight is what's missing from this saga. What's missing from this platform is all the sources of monetary value that we use in our day-to-day lives, with the exception of the US dollar. Where are the mortgages on chain? Where are the treasury bonds on chain? Where are the supply chain certificates on chain? Where are the insurance certificates on chain? Where is the entire goddamn capital markets that powers the modern world? Where is it? It's not on chain. And it's not on chain because blockchain is fully transparent. If you are mediating or settling an asset that is anchored to the real world, then for a smart contract to perform that settlements layer, that smart contract needs to know who the owner of the asset is. It's not enough for me to say I am OX3ABB112, you know, whatever my address is. That's not enough. I need to be able to say, hello, I'm Zachary Williamson. I'm 37 years old. I'm a British citizen. I'm not on a sanctions list. I'm not a terrorist. And right now on Ethereum, on other platforms, you can't do that without doxing yourself. This is why you need privacy. Privacy is identity. Identity allows permissionless, decentralized smart contracts to understand who somebody is and can therefore become the trustless medium on which we can execute our real-world transactions and exchanges. And so how do we pierce this Web3 bubble? You know, how do we turn blockchain from digital Las Vegas into digital America? And I think it's fairly straightforward, to be honest. Step one, we need to be able to interface with Web 2 systems. We need to be able to take information from Web 2 servers, from the internet, from emails, pipe it into smart contracts trustlessly without disclosing information to the world. Using that, you can do things like solve account abstraction with Web 2 authorization techniques. For example, in Aztec, you can write a smart contract that performs a Google authorization flow, sign in. So you're basically saying, hello, I have a certain Google account. And the world can't see that you're doing this. They can't see that that contract is linked to a Google account. And for a casual user in a hot wallet, that would definitively solve the account issue because it's tied to your Google account. There are obviously certain centralization risks there that need to be navigated, but that's just a token of the simplicity of user experience that you can get with privacy. But the main thing is you can prove data provenance from the outside world, from the real world in Web3, trustlessly, via these kinds of zero-knowledge oracles. And then once you have that, you can start to link accounts to identities. You can link personal information to Web3 accounts like your citizenship, your Web3 credentials, even things like if I can prove in a smart contract that I possess a Twitter account with over 100 followers, that means I'm probably not a bot. I might be, but I'm probably not. And that itself, that is useful. And if you have more advanced identity systems, you can unlock decentralized apps that can interface with the real world, bring real-world assets on-chain, and use them as liquidity inside DeFi-type applications. That is the Holy Grail. And once you do that, you can meaningfully start to establish digital sovereignty. The idea being that a digital ownership of a digital asset on-chain represents a legal claim to property in the real world. That's the final stage of bringing the world's transactions and exchanges on-chain. So building a missing link, I'm going to talk about this in a bit. This is Aztec, basically. You need a private blockchain. You need a blockchain with private information that's powered by zero-knowledge proofs that abstracts us all away from the developer and the user. So as a developer, I can write a smart contract on Aztec using Noir, our programming language, but it's just a regular Rust-like programming language. I don't need to know ZK or Moon Math or anything like that. I just need to be a Web3 engineer, and I can build and deploy into Aztec. And using our technology, the network's users, they're generating these transactions using zero-knowledge proving client-side, using our state-of-the-art technology. But they don't really know this. It all just works. So the final thing I want to talk about is I want to explain identity in more detail, how we're thinking about identity on Aztec. I mean, what has digital money got to do with identity? Well, identity is all about credentials. In the same way that right now Ethereum is the canonical source of assets on chain, our goal is for Aztec to be the canonical source of credentials. If you have to issue a token which says something about somebody, and what they've done, or their future intents, I think Aztec is the natural place to do that because it's all private, it's easy to query, and partnering with organizations like Wormhole, you can very efficiently bridge into and out of Aztec to basically use Aztec as a privacy shield for any other blockchain platform. So how do you do identity in the traditional way? Well, traditional identity, like let's say if one was going to go to the state government of Nevada and say let's do ID, they would first develop an identity standard. It would be a very complicated document, a few hundred pages long, very refined by multiple stakeholders, approved by some authoritative third party like NIST. And then that standard would be used for years without any kind of changes because the coordination cost for changing things is far too high. To give an example, social security numbers in the US was made in the 1930s, is woefully insecure, but it's still used because it's just too damn hard to change. And this means that a lot of potential use cases of this digital identity aren't captured because they would need slight tweaks, they would need slight changes that were not considered by the original designers. So here's how we want to do it on chain, the distributed way, the holistic way. The idea here is that, well, if you want to build an application on Aztec and you need privacy, and you need some kind of identification process, it's going to be very custom to your application. It's going to be very bespoke. And so we want to create the tools and the resources to make it easy to develop. So you can build an identity system that's very specific to your needs. And in a thriving ecosystem, you'll have hundreds, you'll have thousands of entities doing this for their specific asset types, their specific user types. And what will happen eventually is twofold. One of them is that popular protocols that stand the test of time, their means of identifying people might become standardized, either formally or informally. In the same way that, for example, ZK Starks and ZK Snarks, cryptography, these things don't have formal standards, but they certainly have informal standards that the whole industry is very well aware of. But then, what I think is very important is this concept of holistic identity. The idea being, if you have thousands and thousands of different products and applications and services issuing digital credentials that are custom to their use cases, you can start to then create meta credentials. Wrappers around multiple of these credential types that start to say something more about somebody else, something more interesting, something more complete. And in doing so, you can get, I believe, very strong understandings of somebody's identity without having some kind of grand central issuer of that identity that has a lot of control through this distributed permissionless process. In the same way that you can build diverse applications on Ethereum, which can tap into a large number of other applications that other people have built, you'll be able to do the same with identity. And this is a very different way of operating to the existing real world, where I have a passport. Again, it's like centrally issued, centrally specified. Any problems with that specification from 2000 or whatever, well, you just have to live with them. This is much more flexible, and it plays to the strengths of blockchain. It plays to the strengths of decentralization. And so next year, when Aztec's live, anyone will be able to issue a credential in the same way that back in the day anyone could make a digital asset. And I think this is going to be revolutionary. Yes, I preempted. I front-run my own slide. So for example, let's think about identity. You want to bootstrap it. In countries like the UK, probably the US, where you don't have strong, unified ID standards, how do people do it? Well, you do things like, you might need to provide a couple of utility bills to do proof of address. Well, there's no reason why you can't take those PDFs, put them in a ZK proof, do some basic language, like some basic text recognition algorithm, and validate, yeah, okay, this is a utility bill from a known provider, and it's got my name, it's got my address, and you can basically just create a ZK proof of that proof of address without disclosing information, which is great. It means you don't need to do you don't need to like create things from scratch. We're just bringing the existing process onto the world and bringing them on chain. But this is like a massive coordinated effort that will need to be engaged with by hundreds, thousands of people, because each identity system is very bespoke and very unique. Okay, so I've been talking a lot about identity, making blockchain real, making it useful. But there's something much deeper at play here, which is that blockchain right now is suffering, in my opinion, a spiritual death of sorts. And we can analyze this by looking at the mythologies of blockchain from the past and the present, and the stories we tell ourselves about how blockchain will evolve. You know, the old tenets of blockchain, the old canon, was all about censorship resistance, decentralized governance coordination, radical privacy. It was a technology of protest. You know, you go back to 2008, 2010, and like, you know, people today like to talk about being anarchists or cypherpunks or whatever, blah, blah, blah. Back in the day, they were building things like Silk Road and using Bitcoin to settle like extremely illegal payments. I mean, regardless of the legality of that, they actually practiced what they preached. It was very hardcore. Perhaps not very scalable, but it was hardcore. And the whole point about blockchain was that it was a combination of a financial technology and a social technology for organizing ourselves, coordinating ourselves. Today, we've lost that social aspect. Blockchain is becoming more financialized, where we're entering the era of the institutionalization of crypto, where you have things like the London Stock Exchange Group, you have Ethereum ETFs, and more and more enterprise coming in and participating on blockchain, which is a good thing, but also a bad thing, because it slightly degrades, in my opinion, the value proposition of blockchain. Blockchain was always supposed to be a technology where we could create new institutions that could contest existing financial elites using the efficiencies of blockchain, of trustless composability. And nowadays, what we're actually seeing is more of a drive to see how blockchain can serve those existing institutions and not disrupt them. And I think that's a difficult change, because the end state of this is that if things like, if it becomes fully institutionalized, if, for example, all the transactions and exchanges move to networks like Tempo, then all blockchain has become is a slightly more efficient settlements layer than Visa, which is not why we're all here. We're here for something more than that. And so I believe that the missing link is privacy. Once you add privacy into blockchain's mythology again, you can start to build meaningful technologies, products, institutions that get back to the core of what blockchain is supposed to be. I think Aztec is a living testament to this. We're launching, we've already launched really, we've done ignition, we're producing blocks on Ethereum, and we're launching fully decentralized. Right now, Aztec, like the institution, has no control over the governance of our network, and it's fully unkillable, like Ethereum. You can start to actually create DeFi-compatible real-world assets. You don't have to rely on the traditional titans to syndicate stuff on chain and do this complicated financialization. Random people can do it. You can do it on Aztec. And this is what we want to see. We want to see distributed ledgers, permissionless ledgers, become the global payment infrastructure layer, the global layer for settlements and exchanges across all assets in the world. So privacy, I think, is the missing link. I've been talking about this a lot, front-running my own slides again. And I think it's the core value required for blockchain spiritual revival. We're seeing this with Ethereum and Vitalik pushing privacy hard, and the Kahaku team integrating privacy into Ethereum. They understand it's a core value. And it's being used to build the future of Web3 today, not in the past. It's not a future thing. You can use ZK today. You can build an Aztec today. You can use Noir today. So this is something which recently happened, was a bridge from Sepolia, from Base, to our DevNet. Again, this thesis that we can use Aztec as a privacy shield for every other blockchain layer, and that it's very, very positive sum. Aztec is in development since 2009. We're technically fully launching early next year with transactions, but we already have block production on chain today. And yeah, we're going to make Ethereum cypherpunk again. I think not just we Aztec, but us, the whole community, is pulling in this direction. That this privacy tech will be used to develop systems and protocols that increase human autonomy and agency, that make us the custodians of our own data again, instead of just being these commodities that are farmed for our information on chain. So something which I also need to add before I finish. So yeah, as I said, Aztec is live today on mainnet. It has been a culmination of 7 years' effort. We're doing this for 7 years. And as you may have noticed online, we are currently doing a token sale. The public sale starts on December the 2nd. And I must fulfill my responsibilities as director and executive to say that. But yes, I think the future's bright. We're gonna revive the core values of what made blockchain great. Thank you very much. Thank you for listening.
Thank you so much, Zach. I think the key takeaway that we have is that privacy is not a nice-to-have feature, but a core for the future digital identity. Thank you so much. Are there any questions in the audience? Yes, over there, please.
I thought it was really interesting when you talked about the sort of myth-building aspects. I guess, what do you feel like were the core engines of the early stage myth building that you admired versus some of the engines that are maybe missing now to sort of build better myths in our contemporary time?
That's a great question. So what engines were active in the early days of blockchain to build myths compared to, and what's missing today? I think a lot of it is basically cynicism and jadedness. If you think about what happened, like the early cypherpunks, people like David Chalm, Hal Finney, they were very ideologically driven. They're talking about, literally, they wanted to contest the right of the nation state to issue fiat currency. And they succeeded in that regard. If you went back to 2007 and you asked the American government, hello, could I mint my own currency? They'd tell you to get lost. Sometimes it's better to ask forgiveness than permission. But what honestly happened was a legacy of failure. I think one of the problems of blockchain has been sometimes we're not the most self-aware community. And I think, for example, the scene was set with the DAO hack. The DAO was this very ambitious project to do decentralization, decentralized investment funds, and it broke. It broke pretty spectacularly. And I think that ultimately the problem is the technological base layer that everyone's building on top of is a little bit too weak to realize the grand ambitions. So the original cypherpunks, yes, they could build technology that could do money. But it turns out governance is a lot harder. Human beings are a lot harder to coordinate. I think, for example, things like if you make a DAO today, you can't easily do a private payroll. You can't pay your contributors privately. What the hell? If you're doing a vote on chain, you can't have private voting, so it's open to grading and manipulation. The governance modes of a DAO on chain are plutocracy or oligarchy. As in plutocracy, tokens vote, you can buy tokens. Oligarchy, it's a multi-sig. These are terrible governance models. Who here wants to institute plutocracy in their own country or oligarchy? You need to, on-chain institutions need to know who their stakeholders are. They need an understanding of who the people are that are contributing to that DAO. And that requires privacy tech. It's not the full solution, but it's an ingredient that's required to make it succeed. And so what we need to revive that engine is we need more success. we need to build products and systems that actually fulfill that original thesis of blockchain as a social technology to create that spiritual revival.
Thank you so much. Next question over there, the gentleman.
Yeah, thank you. Amazing presentation. What are the trade-offs that you see between layer 2 or layer 1 privacy versus protocol level privacy that Kohaku is building, right? And where do you think we will see more adoption first and maybe cascading later? Because you have similar solutions, ZK Connect before, Aztec Connect. So curious on your thoughts.
So what's the difference between the privacy of something like Kohaku or a more network level like Aztec? I'd slightly turn that around. I would say that ASIC is the protocol level privacy and Kohaku is application level, because it's something you layer on top of your application, but it's not going to be something mandated by the protocol to be used. And I think what's really needed for this to really take off is you need private composability. As in, I need to be able to write a smart contract that has private data, and that my smart contract can call another smart contract that operates on private data that somebody else wrote. And then that thing can call another smart contract. And it all just works out of the box. And at application level privacy, you can't have that, not easily, because every app has their own custom tool chain to create that privacy, to make the zero-knowledge proofs, to reason about private state, which creates this complexity explosion if you're trying to coordinate multiple privacy solutions that are all coordinated at the app level. It needs to be brought into the protocol, in my opinion. The protocol needs to have an understanding of private state so that the actual core node software can handle like all the requests and queries to manage private states, where you can easily call private contracts or call private contracts. It's basically just makes the developer experience a lot more effective and efficient. And I think that's required for privacy tech to scale.
Thank you.
Yeah, I'm afraid I think I've got to run. But,
in case you have more questions, I think Zach from AdSec, they have a booth out there, so he's around. And yeah, thank you so much.
Thank you so much, everyone.
For like short minutes, 5 minutes break, and then the next speaker will come.
to meet you.
Nice to meet you too. Your name?
Rodrigo.
Andres.
Andres.
Yes. Should we start now? Okay. Our next topic will be guerrilla interoperability by Andreas, and he will talks about apps using built on the Ethereum and thus reducing the centralization of the internet. Welcome on stage, Andreas.
Hello, hello. So, thanks for coming to the talk. I think I'll be quite direct with my presentation. I'll go straight to the point. So, the title of the talk today is Guerrilla Interoperability. I'll explain very quickly what it is. Just a quick introduction. I'm Andreas. I'm one of the co-founders of Fileverse. We're the ones behind ddocs.new, dsheets.new. We're alternatives to the Google Workspace, and we're providing end-to-end encrypted and decentralized alternatives. So, let me get to the talk. The premise of my talk is really that a good majority of the internet is now filled with hostile architecture. What building?
Of course, none of.
Definitely. How's the energy? Are you here? All good? How was Ravi last night? Did you recover well? Great. I think the guys are still setting up, but Mike can already announce them. The next talk will be about 0x address parity, and they will talk about how to make private addresses as good as public addresses. And the presentation will be presented by contributors of Railgun. Guys, the stage is yours.
Yay. Can you guys hear me? We're good? Audible? Sick. So we are contributors to the Railgun Privacy Project. I got a couple of us up here. We're going to try to not get too in the technical weeds, but we'll try to share a little bit about what it is that Railgun is and how it works, and show off some cool new tech we've been working on for several years. So I'm Alan, and then we have Kai, and then we have Zion. I'm basically Tweedledum, and these are our two Tweedledees who are highly technical. And to tell you a little bit about Railgun, it got started back in 21. It's a privacy mechanism for DeFi, and what it allows you to do is have a private address that you can interact with DeFi without doxing yourself. So if you want to take and send people tokens, receive tokens, do swaps or lending or farming or provide LP and not dox yourself, you are able to do that. And I think that that's a really, really cool functionality. And I think that one of the key things about Railgun that makes it really unique in the privacy space is the architecture of the contracts. And I think that I want to let Kai maybe talk a little bit about that, if you wouldn't mind.
Sure. So the really cool thing about Railgun is it's a full private address system, right? And what that entails is there's not like, you know, in the past, maybe the approach has been like, all right, well, you kind of have some note here, you save some private value, right? And then like you go and redeem it later. What Railgun allows you to do is, you know, have a private balance, private address, you know, like a private history that you can go and view with your private key, send and receive, right? And while like in the past, like it might have been good enough to just have this this private note that you maybe like save in your like notes app somewhere or whatever. There is a full private key within Railgun. That means you can do cool stuff that's probably about to be demoed here that you could do with like regular signatures.
Yeah, I think that's kind of a key point, and effectively, having this sort of like key separation and zero knowledge separation, what it allows you to do is, I guess it allows a lot of flexibility for signing, right? So you can do, well, we're going to show it off here. You could do hardware support, so you can have a message signed on a piece of hardware, and then perhaps on a more performant, say, laptop or something like this, do all the ZK stuff, right?
Yeah, so there's kind of like this separation in the railgun design. So the actual step, which is like the authentication, right? So signing the transaction happens separately to the step which enables privacy-preserving aspects, right? So you can sign a transaction in a hardware wallet, and then take those outputs and go prove them where you have more compute. Like on a laptop or like mobile or whatever other client device.
Yeah, and so I guess Zion, we've been doing a lot of this research for quite some time, and more intensely in the last couple of months than the last couple of years. I guess tell us a little bit about the way that we've been using this flexibility to sort of like unlock hardware wallet support and multi-sig support for private addresses.
All right, so it all really started with multi-sig support, and once we had brought that process along of understanding how we would ask the external signers to interact with the wallet and then bring the signature to the prover, it was more of just like a fall in line method with the hardware support. It basically worked upon the same aspects. We're doing the signing somewhere else and just sending it back to the wallet that desires the signature.
Yeah, and I think that's really, it's really, really cool. I kind of want to drive it home a little bit though, but like privacy is a sort of big deal in the land of finance, right? I think one of the really cool features of this is what it allows you to do is have a multi-sig where you're not doxing the signers or the balances, which is a really big issue in crypto. If you're a known signer on a multi-sig, this is a pretty dubious thing for it to be known of you, and so it's sort of a very interesting unlock in the space. I guess, do you have any final thoughts before we take a look at it?
No, let's get to the multi-sig part. Or this is the multi-party computation of your shares. So this is the application that we are producing for handling and managing your signing events. This login here is just a authentication system to access your underlying private database of shares within the local storage. So it's not related to your underlying shares at all, and it's not doing any signing under the hood to produce any of these signatures. So in this process, it's a coordinatorless DKG system. DKG is distributed key generation. Yeah. So one party creates the session, gets the encryption keys, and then passes it off to the desired parties who are going to be participating and owning a share of this wallet. So the creator decides how many people he wants in this wallet and what the threshold will be, and then the participants join in and receive that, and then once everyone finishes the join process, the coordinator reaches back out to everyone and says, hey, here's your ID in the sequence, let's move forward. Let's start creating our shares. And we'll get to see that here in a moment. It's quite fast, actually.
So I guess while we're taking a look at this, maybe Kai, you can tell us a little bit about the Schnorr-based signatures that we're using here, Frost.
Yeah, so in Railgun, there's two private keys that get derived. One of them is a viewing key, which allows you to decrypt your private balance. The other one is a spending key. The spending key is using EDDSA signatures over Baby Job Job. So a really cool thing that you can do with that is because it's a fairly standard, fairly well-known signature algorithm, you can do things like the Frost or Musig, like Bitcoin One, or any sort of like Schnorr-like signature scheme. Over here, it's the implementation of Frost that's being demoed, but any of those should work.
Yeah, so what we see here are the secret keys that will be passed into the Railgun wallet. The shareable viewing key, most of you, if you're already a Railgun user, you would know that you can pass this off to some external firm or accounting software system to actually read your private transactions and then not be able to sign with them, but just do accounting for you. So the viewing key has nothing, no part of spending. The personal multi-sig key is an adaptation of that ease of use, just one entry like load of your new wallet. This key has the symmetric key and the ID encoded in it, and along with your private ID. So the last value there is your ID. So it's 01 and 02. These are the signers of this multi-sig. And we'll move on to actually demonstrating using these here. So here we've already loaded up the wallet to save time. It takes roughly about 5 minutes to load a fresh Railgun wallet. We're signing into the share signer. Is this? So now we're attempting to connect the ledger. It's a lot of hand waving here and magical stuff in the background, but what it's doing is getting your shareable public key from doing some EDDSA signature stuff in the background, and then producing your viewable public key that can be used in the Railgun wallet. So what we're going to do here is, from the ledger, we're going to send the new multi-sig wallet that we just created a little bit of funds. Receiving wallet.
So I guess I'm curious, like, what you think of, like, you know, so the name of this talk, right, is like public address parity, right? And the whole point of this is a lot of like privacy systems don't have robust functionality, and so what this leads to is a sort of problem for people wanting to leave funds private for an extended period of time, or be able to deploy funds from a private address however they might see fit in DeFi. And I guess I'm wondering, like, in terms of like unlocks, well, how would you say like this is for you know, for like usage of Railgun?
I see it as a huge unlock because it allows multiple people to take ownership over a single account. That brings to the table a lot of different styles of usage. Funds, DAOs.
Of a 0ZK address, right? And so with hardware wallets support and
not only a I guess a software signer, but then also having a piece of hardware alongside of that, because I believe that's sort of like the status quo of like transacting in DeFi today, which this sort of enables, right?
Yeah, that, and also just being able to shard out a single private key that you already know. You can then have backups anywhere in the world. Like, you could take a single private key, make it a 1 of 5 shard, and then store these out in separate places. Then if you lose your mnemonic or any of your private keys, you have access to that wallet completely with just one of those shares. So it's forward, future holding of your assets.
Yeah, and so I guess with Railgun, there's a lot of really great on-chain privacy associated with the mechanism, right? But whenever you have something like multi-sig, you effectively have to take and like communicate and coordinate the signature of this. I'm wondering if there's any sort of like consideration for like privacy for like sort of like passing these messages around to each other and coordinating and setting these keys up.
Yeah, so it's a fully private messaging system. In the traditional way that multi-sigs are operated, no shadows on safe over there, but that signing process is on-chain or in a public ledger that other signers can see and know what's happening. This whole process happens behind like an encrypted session channel using Logos messaging. And with that, the parties are able to interact with asynchronously in the moment. One, due to the fact that Railgun transactions they happen live, and when you're using a broadcaster, there's a window of time that this transaction is actually valid. So the waiting aspect is not really Railgun. Give me a word here. It doesn't really work well with Railgun. But it does. So what we've done is have this asynchronous encrypted communication between all parties allow us to do this, and nobody's the wiser. The only people that know who's signing the messages are actually the participants that are partaking in the signature itself.
Yeah, which is sick. We're super excited about this stuff. So what do we have here?
So here, we are actually loading up the multi-sig wallet that we just funded with the hardware wallet. And we're going to use the two signers to send a transaction back to the hardware wallet. So this works on your mobile device. It's actually relatively fast. This changes the way that we can think about Railgun wallets. So the signing process can happen on a trusted local device, and the proving can happen in a more in a higher grade computer that you own, or it can be passed outward to be proved. Sorry, I'm running out of smart things to say here. So now we're waiting for me to do the approval on my phone. That video didn't actually save properly, so we'll just wait here and watch it all happen.
So I guess while we're checking this out, I'm very curious, like where, I guess, this is a really sick proof of concept, and there's definitely a lot of potential here. I'm curious, Kai, what are your thoughts on like moving this forward into like a full-on production style architecture that people will see in the SDKs?
Yeah. So there is an effort at the moment called Reloaded, which sort of takes a lot of the sort of monolithic design of the current community SDKs and makes it a lot more sort of like pick and choosable, sort of Lego composable. And what this allows is also with things like this to swap out like just a traditional same device software signer with alternative signing backends, right? So like the multisig or the hardware wallet, and you could also take this and sort of like port this out to other hardware wallets too, and maybe even like if you're really paranoid about your security, combine a couple of different hardware wallets, right? Don't like rely on just a ledger. Do like a ledger and whatever else.
Yeah, get your Ledger Trezor Keystone signing setup ready.
Go old school here. Not your keys, not your coins.
Yeah, totally. Well, we appreciate you guys coming to listen to us talk. This is a lot of fun to work on. This sort of work is, I don't know, 3 years in the making. Figuring out multisig for private mechanisms in DeFi was a big pain in the butt, but there it is. It works. And if you want to hear more about it, you can come and check us out in the privacy section over there. We're all hanging out and coding stuff.
Thank you.
Can you hear me? Thank you so much, guys. Awesome presentation, live demo. Any questions from the audience? We have time. Hello? Guys, you're still with me. Friday evening, I think we have the last talk for today. But last but not least, hello? Can you hear me? Last but not least, we have the next presentation of Petra, and he will talk about the state of the art of a prediction market. Petra is from the company Precook. The stage is yours, and we have 20 minutes time, and after this, we have 5 minutes Q&A. Yeah, so take notes so they have questions. Petra, the stage is yours. Thank you.
Thank you for coming. Well, we did a little change. We were going to talk about privacy, but we switched to go a little bit more zooming out on why we're doing prediction markets today. So we're doing the state of the art of prediction markets. Until now, decision making has been done with narrative, vibes, and biases, but we want to do something different, and prediction markets enable us to do that with skin in the game and rewarding truth. This we consider is very important for society because we want to overcome the post-truth era and enable truth-seeking behaviors. We think that will enable a lot of better decision-making and improve our quality of life. And one of the big questions is, what's the difference between prediction markets and gambling? And I know this is a fair question, so we will address it. Basically, it's because prediction markets are part of info finance, and the main difference is that it can be learned. People can learn, study, get better at predicting the future, and it's not just random things. And the second part is that it generates positive externalities. What we mean by that? People not only trade and buy and sell options about the future for fun, but it creates very accurate predictions about the future, and that's the whole reason why we're creating prediction markets. Well, oops. We're going to look into the good, the bad, and the ugly from prediction markets, so it's a little bit of a fun introduction. The good is that anyone can publish a signal. This means that it's open for anyone to participate, and also it enables transparent consensus. It enables collective truth-seeking mechanism. So basically, as I was saying, it's part of InfoFi, but it's also part of info defense. That is an important feature within DIAC. Basically, it enables people and groups to avoid groupthink, that is everybody thinking the same thing, and also it helps to diminish biases. The bad is that right now we have to solve resolution systems. We have to improve a lot how we resolve the markets, and there is a lot of research going on here, but still we have a long way to go, because if you don't have a good way to resolve, you start not rewarding good predictors and people looking for truth, and the system is not rewarding what you want to reward. And also the second part that is bad is that institutions are fearing uncontrolled truth, and it's something that we should change culturally for institutions to start embracing truth and embracing tools that showcase truth openly. And the ugly part is that, as we know, prediction markets are very fun for some people, but also they drive a lot of dopamine. So designing these systems in ways that are not making people draw on dopamine and make them focus on long-term decision-making, long-term research and focus to get better decisions. And the other part that is not so good is when we only focus on trading. It's a very important part of the process, but it's not the only part. We have to also focus on good forecasting, on accurate results. That is basically why we're here, to create good forecasting outcomes. okay, these are the problems that we saw, and there are some non-intuitive design choices that we can make to improve some of these issues. The number one is early closing to avoid obvious markets. Basically, obvious markets is when you have 99% of an outcome that is it's obvious already. Like there is nothing that you're predicting. So a way to avoid this is to close the markets early. For example, in a soccer game or a football game, you don't want to close it at the end of the game because it's already obvious who is going to win. You want to close it beforehand, and this is important so people can earn from predicting well, and it's not just earning for being fast at reacting to reality. Then another one is that resolution systems and oracles, and we have two parts from this design space. One is the problem that is that when oracles is the only option, and basically we have a very interesting use case, which is that they were betting on Zelensky's using a suit or not in a conference. He wears something that looked like a suit, but because the resolution system was only based on game theory, and it was the only place to solve it, there was a lot of problems, a lot of come and go, and basically the solution is to have a two-stage system. Something that we implemented at Preco is having reality.eth as a first stage that is similar to the system that resolved this thing from the Zelensky suitcase, but we also have a second part that if people are not happy with that resolution, they can use Kleros as a dispute resolution. And the second case for resolution systems and oracles is that oracles deploy delay resolution. This happens when the oracles want to take advantage of the market. A market is already, the reality already happened, everybody knows what happens, it's already an obvious market, it goes to 99.9%, and then the oracles start delaying the resolution so nobody can cash out. And the problem with this is that people start selling at a discount, let's say 98, 97 cents, and then the oracle people, basically whales, can take advantage and get those shares at a discount, and then solve the market and profit that 3%, 2% over a couple of days, which is huge. And the way to solve this is to stop trading markets after they close. So once it's closed, nobody can sell, nobody can lose, and so there is no incentive to delaying. Another of these design choices is to use multi-outcome pools to avoid arbitrage. Basically, nowadays, when you see many outcomes in a prediction market, each one is a pool, and something that we're doing different is we have one pool for all the outcomes. When you have different pools, as in traditional prediction markets, when you buy one of the pools, there are bots that arbitrage all the other options, and that's profit that the trader or the predictor is losing. This happens in the binary prediction markets, but with multi-outcome markets, basically you have one pool with all the options. So if you want one, if you buy one, all the predictions, all the probabilities of the other markets, of the other outcomes, decrease. And this is basically very efficient because there is no arbitrage opportunity in between. Then another one that we think is very important is how we align incentives through market profit. At the end of the market when it closes, basically you have the whole pool of liquidity. First, you pay to the people who predicted right. Second, you pay to LPs. And third, you pay to the people creating the question, and then to the people and to the protocol. So in this way, everybody participates from the same profit pool, and everybody's aligned to create good outcomes together. It's not like different parts of the system having different incentives. And the last one is the one that I'm most excited about, that is decentralizing editorial power. Basically, we have like this meme of like Web 1, you can read, in Web 2, you can write, and in Web 3, usually we say you can own, but I feel something that we're missing all the time that is super important is that you can own and deploy. We have seen this with ICOs and with NFTs and now with TGEs. Basically, you can deploy smart contracts, and in this case, you can deploy markets, which is insane. Like you can now deploy a microeconomy about a question and reward people for being right. And that's something that we're quite excited, and that's why we have created a launchpad. Okay, this. And we are trying to do these transitions for content creators to market creators. We think that people can create their own market and they can put like very good information out there from this process. That's why we say a lot of the traditional or incumbent prediction markets are more like New York Times, and we're more like Reddit, or for Argentinians, Taringa, that is basically this grassroots and more community-oriented way of creating information, creating content. Well, let's basically, the closing idea is that Precox North Star, why we're doing this, is because we want to reward signal, accuracy, and coordination. And if you're excited about these things, I invite you to follow us, join our journey, and yes, and ask questions now if someone wants to ask something. Thank you. No? I can moderate myself.
Can you hear me? Okay, okay, sorry, it works. Yeah. Thank you so much, Peter, for your presentation. Time for questions. Don't be shy. No question, but did you pay attention or did you listen?
No.
Jose, do you have a question? No? I know some people from the audience. Yes, the gentleman down there has a question. Can you please pass him the mic? It's coming, it's coming. We can't hear you.
No.
Oh, do you want to use mine?
Now we can hear you,
right?
Yes.
Yeah, now it works.
Any airdrop for Zelensky voters who got wrecked?
I don't have anything to do with that protocol, and yeah, we're not doing an airdrop anytime soon. We could create a prediction market if they will do that on pre-call.
Another question unrelated. I have been thinking about high-frequency prediction markets, like, for example, as the game is going, agents could actually change their estimation of a probability of the outcome throughout the game, like every second, basically, which humans cannot do, but agents could. Is that something we should be trying to like innovate at already, or is it kind of too early yet?
So innovating what? Sorry.
Like creating high-frequency prediction markets, basically.
Not the bots, but the markets themselves. I think
both.
Okay, okay, because it's quite different. I feel that for the prediction markets, the shorter you make them is the part that I was referring to, that it leads to dopamine. If it's just for ancients, maybe yes, but many times that people are trying to do very short prediction markets, and it's just for gambling, basically. It's just for fun, and it's not trying to predict anything, because you cannot gather enough information for most of these things. It's like ETH price or Bitcoin price. If you're doing like a 5, 15, 30-minute window, there is not enough. Like if you could do that, you probably wouldn't do it on prediction markets. You would like just buy the underlying asset you're predicting, right?
But if it's like a football game?
If it's a football game, that's, yeah, we joke internally that those are description markets, because they are just reacting to reality and they're not predicting anything. So it's, I feel there is a use case for that, but it's not what we're trying to do. We're trying to do build something that you can predict, and you can reward people who predict very well to make decisions. So,
do you think that the role of agents will eventually flip the role of human predictors?
I think the trading in general is very hard for most people against a very fine-tuned mechanism. It doesn't even have to be agents. It's like MEV on blockchain. Yeah.
Does it answer your question?
Yes.
Or you can talk more later on.
No,
I think. Okay, thank you.
Thank you.
I think the lady, you have a question? Yes. She's next.
Where?
Hi.
Hi.
I have a meditation center in China. We have nearly more than 80,000 members offline, and this year we have a plan. We wanted to create our brand overseas. I want to know whether or not has possibilities to create our own brand on this platform to support us to do this part.
Yeah, we have great question. Thank you. We have branded markets for communities and for protocols. So if you have your own token, we're not enabling meme coins or very fluctuating tokens, but we are interested in some protocols tokens to predict their own communities, information, KPIs, and different things.
So it need KYC or not?
Sorry?
Need KYC or not?
I don't.
KYC.
KYC. No, we're not doing KYC right now, but we're mostly like hand-holding people. We're like onboarding people one by one.
Can I connect you more later?
Yes.
Yeah.
The gentleman behind there has a question.
Hello.
Hello.
I am seeing that prediction markets, and especially pre-COP, can be a good building block for what's coming next in the future, in the same way that you are using Kleros as a building block. One very interesting use case for prediction markets would be the creation of a Futarchy DAO, or which basically is a mechanism in which the governance is vetted first, like who is going to be the best governor from now on. The one that is predicted to be the best, it's the one that is going to govern. But I am very worried about how it can be manipulated. Like, if you have a big bag, you can predict that you are going to be the best governor. How do you see that it can be prevented to be this manipulation on a prediction market?
Yeah, thank you. Yeah, I think that's a great question. We have all asked that question at some point. And first, I'm very excited about Futarchy. I feel that we should bring Futarchy to the EVM. I feel that we don't have many Futarchy projects, and I'm excited to have more of that. And regarding that, the specific questions, I feel that it depends a lot on the volume of the market. If you have enough volume and someone tries to manipulate it, that's profit for another part, as long as you have good resolution at the end. And that's why we focus so much on having good resolution systems, like you are sharing with Kleros and Reality.is. It's because if you can resolve something well and you are like, it's not going to be manipulated, the incentive is always to bet on what's going to be true and not bet on to try to manipulate it, because on the other side, if there is enough liquidity, they will eat your bet and you will just like lose all your money.
Yeah, also otherwise, politics is always putting money in your political campaign, so it will be a very similar system at the end, right? Even if it was this way. So thank you for your question.
Thank you.
Any other question? The gentleman over there has a question. Now the questions are flying in.
Hello. Hello.
Hello.
Yes.
Nice talk.
Thank you.
In your
presentation about some non-intuitive design choices. You were talking about closing some markets early when they are trading at 99 cents, for example. But there is a problem is that there are two different types of markets which are trading at 99 cents. There are some markets which are trading at 99% probability because of the time value of money. And for those markets, it makes sense to close them early. But there are also some markets which are trading at 99 cents just because there is actually a real 1% probability that the opposite of the events happen. For example, I'm thinking about earthquake markets, which were some markets on Polymarket which were trading at a very low value, and then the earthquake happened at the end of the month. So could you explain more what types of markets you will decide to close early? And how will you know if the market is trading at 99 cents because of the time value of money or because of the 1% real probability that the opposite of the event happened? Thanks.
Thank you. Yes, basically when you design the market, you decide that it's not that you wait until it's 99 and you close it, more when you're designing the market, and that's why we are onboarding people to create their markets and hand-holding them, because there is a lot of a steep learning curve at the beginning on a lot of these non-intuitive things. And one of them is when you decide to the closing and opening dates, you need to take this into account at that moment. It's going to be obvious market or not at some point, and most of the time you know in certain dates it's going to be obvious, so you close it before.
So it would be something that is included in the rules, for example. Like the rules would say if it is obvious for whatever reasons, the market would be closed.
Sorry, what?
The markets would be closed early because of something that is included in the rules to say it's obvious for that reason. It wouldn't apply for all markets, right?
Exactly. It's not for all markets. There are specific markets. There are like two types of obvious markets. Ones that are collapsible, that is like, for example, you have many dates, and it's like, okay, if it hits before, it's going to become obvious, and it's just part of the game. You cannot do anything. But there are some that if you close it, like an election, soccer, like many, like sports in general, many things that you can close it right before the event starts, and you avoid that problem. And it's also a tough decision because probably is where you get most of the trading volume, but also you have two positive outcomes. One is that you don't incentivize a lot of dopamine, like last-minute dopamine betting. And on the other side is that you're really rewarding good forecasters. You're not rewarding someone who acts fast because they betted because they have like some bot or something, but it's like, okay, you studied, you research it, and you get that profit because you are good at forecasting the future and not just because you're fast.
Thanks.
Thank you.
Thank you so much. I think time is up. No more questions. I mean, Petra is still around at the booth, so you can reach out to him. Thank you so much for the presentation. Thank you.
Thank you.
I think that's a wrap. We are done with all the talks for today. Yeah, it was lovely being your MC for this stage this afternoon. And yeah, enjoy your time. Thank you. Bye.